Hello, welcome to the SciPy tutorial on HoloViz, helping you visualize all your data easily from notebooks to dashboards. I'm James Bednar. I see icons floating by on my screen that suggest that maybe people are being able to join. If someone's hearing this, please put it in the chat, just so I know that everyone's okay, we can hear it. Great. Thank you very much. All right, so I'm James Bednar, and I have with me, at least for this initial starting period, Philip Rudiger and Jean-Luc Stevens. We are jointly the author of this material. I'll be the presenter of it, but it has contributions pretty much equally from all of us. So you just have to listen to my voice. And these Jean-Luc and Philip will help you behind the scenes. If you're viewing a recording of this later, we have some notes on the screen about instructions to follow. Ignore that if you're not viewing this live. These are the live instructions. If you're viewing it later, just go to holoviz.org and follow the regular installation instructions. It'll all be live on holoviz.org later, but for the moment, this is special sneak preview stuff just for SciPy 2021. It is not on the live website. It's not available to anybody else until after this tutorial is over. So we've prepared this all just for SciPy 2021. All right. So if you come here to attend this and actually want to work through anything, which is what I highly recommend, rather than just listening to me talk, it makes so much more sense when you actually run it. Then the first step is to go to this URL. This is the same URL we passed around earlier. I just put it through a URL shortener so you can type it in if that's your only way to get to it. And so that will tell you, so actually I'll go ahead and click on it to make sure you see what there is to do. And let's go ahead and share my screen. That's probably a good idea. It was shared already, but I'll have to reshare it just a minute. I think it kicked it off when I started it. And
hi, Jim. Could you turn on?
Yeah, it also turned that off. Sorry, I had this all set up, and it turned it off when launching the actual tutorial. There we go. Okay, you should have my beautiful face, and do you see my screen? Okay, great. Okay, that's really helpful, the way the little thumbs up symbols go. That's very good feedback. So this is what I meant to be showing you a minute ago. Actually, someone just said that the video is still turned off, but okay, it's a little slow for people, but okay. So here's my face. This is me. I'm talking, and on the screen it should say https://tinyurl.com/hv-scipy21, all one word. So that's the link to follow. In fact, go ahead and just copy the URL into the chat. That's a good idea. For the moment, Philip, what's the status of the binder link? Is this still true?
It is useful. However, there is one little wrinkle. If you're going to use binder, there is a data folder if you navigate up, and there is a smaller data set which has the extension .1, and you'll have to rename, basically remove the other one and rename that, remove the .1 extension from the smaller one.
You're referring to the earthquakes projected data set?
Yes, I'll update those instructions. You continue on, I'll update those instructions.
Okay, yes. No, this is the same instruction as the SciPy website. This link is just a shorter version of the same instructions. Philip is updating the bit about binder. Binder is a backup. We would really rather you run this on your own machine. You've got a little time at the beginning while I'm giving an overview for getting that running. You're not going to need to run it at this very second I start launching into the material, so don't worry about that. Do try to get it running on your own machine. If you don't get it running, yes, use binder. The reason you'd want to use binder is if your machine has 16 gigabytes of RAM is a great machine to be using for this. If it has less, you might want to open the binder or even follow the binder style instructions on your own machine. 16 is certainly comfortable. 8 should be fine, but your mileage may vary. In any case, you'll follow the instructions here. And this is material that we've been updating continuously over the past month or so. And even probably half an hour ago, I think the last one went in about 40 minutes ago. So those are minor little link fixes, the most recent changes, so don't worry too much. But certainly if you did it any time before this morning, you're going to want to get a new version. And it'll just be easier if what's on my screen and what's on your screen match exactly. So I would strongly recommend following these instructions now, right at the beginning, even if you've already done it. It should be pretty quick to do if you've already done it. The only problem is it will re-download the data. That's not a problem, it just means it takes a little while to download the data. So you just update Conda, you make sure to run Conda install Anaconda project. Turns out there was a release of it that became available this morning. So if you use today's release of Anaconda project, you get a progress bar. That's great, but it's not necessary. So, but if you do update to it, it'll actually give you a nice progress bar. And then you download to the tutorial. This is the stuff we've been working on, which is preparing all the files for today. This is what actually grabs those files and brings them onto your computer, unpacks them, and it puts them in a directory called HoloViz tutorial. And then to actually launch the tutorial, this is the step that actually runs anything. You can leave off Jupyter Notebook. I just put that there so the instructions are fully complete, because you can either write Jupyter Notebook or you can write Jupyter Lab, depending on whether you prefer Jupyter Lab or Jupyter Notebook. It's up to you. I'm only going to use the classic notebook. So this is the command that I've run. Okay, here's, well, I guess you wouldn't hear this, but somebody's asking what to do if there's no sound. If you can hear it, but I guess that'll be taken care of in the chat. All right, so and then the next step after that is to run the setup notebook, and I'll show you all that in just a second. And the rest of this is all going to be handled in Jupyter. So the instructions should end up with you launched into a Jupyter session like this. And I'm going to increase the font size so you can see that better. Okay, and you'll see there were changes to it as recently as 2 hours ago and such. All right, so in order to do this, once you've got this on your machine, you'll click into the tutorial directory. I'll go over this again in just a second, but if anybody is ready to get started, please run through these now so you'll encounter any problems and you can ask on the chat. There was a question, how do you download the project if you don't have Anaconda project? Well, the first step is install Anaconda project, and then you will have Anaconda project. So, and there certainly are ways to get it, but if you have a problem installing Anaconda project, we'd like to hear that first, because that's very much the easiest way to get the project. All right, so the first thing to do if you have Jupyter is to just go through this setup notebook. I personally do restart and run all. And the question is, do you have to install something else after Anaconda? And the answer is yes. You have to do conda install anaconda-project. Anaconda project is a separate command. It doesn't come by default with Anaconda or Miniconda. Well, it might come with Anaconda. Definitely does not come with Miniconda. So you want to install that because that's what will automatically fetch the project. Okay, and I'm just running through this setup. And if I ran Anaconda project myself a minute ago, and it launched this. And these are all going to be freshly run here, and it's running. And if you ran this some other way, it might get to this step and not find the earthquakes data set. You'll need this, and if you run Anaconda project, it should all be fetched for you automatically. There is a Slack channel for questions. It is called tutorial-holoviz visualize all your data easily from notebooks to dashboards. So it's a very long name, but it should be on your SciPy 2021 Slack channels. Okay, any other questions before we dive in more? Let's see. Okay. All right. So show of hands. I don't know. It'd be nice if we could have a count of show of hands. How many people have gotten something running to the point that you can successfully see these little logos? So I can see dozens of, but I can't see what fraction that is of the attendees. That would be helpful. There's a poll function in the upper right. Let us take a poll then. Are things working? Is run setup success? Okay, so there's now a poll. I've never done a poll on this, so let's see. And you only have one or two, you either yes or no. Okay. Oh, that's pretty good. Working on 90, no, it didn't hit 90. We're getting 83%. Okay. All right, that's pretty good. But 20% of 150 attendees is still 30 people to debug. So we'll sort of bifurcate now, and I will stop paying attention to the chat. Philip and Jean-Luc will be messing with the chat. I will go on and present material, but note, I'm not going to present any. I'll tell you and warn everyone, okay, take a breath. Now is when I expect everyone to be running this along with me. So everyone who's got it running, just sit back and listen. We're going to cover the beginning of the tutorial now. Everyone who's not, maybe listen with one ear and the rest of it try to get things running. And and Philip has a binder link there for those who aren't able to get it running locally. And put some notes in here. What are the notes there? Let's go ahead and just share a link to these. Well, Philip, where do you want to put the notes for binder? They're on this.
I've put them in there, and I've shared that link with people.
Okay, great. You're ahead of me. Thank you very much. So I don't need to show this document anymore. That's fine. That was enough to get us started. And it sounds like I'm good to go to actually launch the tutorial proper now. Okay, any objection, Philip or Jean-Luc?
Nope, sounds good.
Great.
And we're on Slack if you need to ask us questions.
You're talking to the attendees, not to me, right?
Yep, that's right.
Great. Okay. All right, so this is the HoloViz tutorial, and I'll go through some background about HoloViz and what we're trying to do with this. But for a start, I'll just sort of show you that HoloViz is an umbrella organization. Maybe our logo, our icon should have been an umbrella, I think. But it's an organization that we created because we'd been making a variety of different projects, each with very narrowly defined focus. And we said, this project does this. But then we made them all work well together, but we weren't able to tell people that they worked well together or how to use them together. So we created this umbrella organization and project called HoloViz that encompasses all the various visualization tools that we're working on here at Anaconda. These are all open source tools. They're all Python focused. Therefore, everything is built around Python users. A lot of them have other things in other languages, like Panel has a whole lot of JavaScript in there. But Panel is written for Python users, and all of these tools are written for Python users. We're really trying to address Python users specifically. And actually, let me go ahead and just launch right into the, I'm going to change track a little bit and go into the overview, because this notebook actually covers a lot of the material that I was about to cover on the fly. So the first notebook is the overview notebook, and I'll switch from here to various examples of notebooks. So I'll go ahead and increase the font size here. So this project, the Holo in HoloViz actually means whole, entire, complete. And we're really, because each of the individual projects is it has a very narrow focus, trying to do one specific thing. And then we're trying to go overall and see where are the gaps? What are the gaps in the process of doing everything? And everything includes importing and cleaning data, exploring data originally, coming up with hypotheses about data, generating figures from that data that are both accurate, so they speak directly to you, and are clear, so they speak to others. To be able to share them not just as static figures, as apps. And also the process, and to take an even further step back is, as soon as you've got anything, what is the process by which you improve it and adapt it and move on to the next thing, whatever the next thing that is you're doing. We're trying to think of all of these things. So we're, the Python visualization tool landscape, you may have seen this slide before from Jake Vanderplas. This slide is showing that Python has a lot of tools already. So what are we doing adding more tools? And so doesn't Python already have all sorts of tools for covering all the different parts? And the answer is sort of yes and sort of no. The thing is that each of these tools is typically isolated to one or two of the ways that you work with data in Python. And like I said, HoloViz is really trying to fill in the gaps and connect everything up, make you have a lot less trouble in your life. And so some of the tools in this chart, there are lots of tools in this chart, probably with names you recognize, like Matplotlib, and we're going to talk a lot about Bokeh. Some of these tools are great for making a simple, quick plot, a one-liner. But then it's just a dead end. You can't really go from there. If you want to make a more complicated one or want to combine plots together and go into more detail, you can't really do it with that tool. You have to switch to a different tool. And then some of these tools are great for publications. They were designed for scientists. I'm a former professor. Philip and Jean-Luc both have PhDs. We've all been deeply embedded in science, and so science is really built around print. But nowadays we're in the business world and we're built around interactivity. And if you have to switch tools to do these things, that's a problem, because you build up a lot of research based on one set of tools, and then you aren't able to publish it when you need to, or you aren't able to make it interactive when you need to. And so that's a problem if you're stuck with a tool that does only one or the other. And then there are tools that are just built right around Jupyter notebooks, like this one that's right here. This tutorial is assuming you already know what a Jupyter notebook is. It's not a Jupyter tutorial, but we'll try to explain if we're using any fancy features of Jupyter. So there are tools that are great in Jupyter, but are not great at all once you try to deploy them separately, or if you try to run them in a batch context where you're generating a whole bunch of static files on disk automatically, say, every night, so you can look at a report later. And then there are some, like pretty much most of the JavaScript tools are great for making a deployed server, a website that people go and visit, but they're not great for interactive exploration of data. If you just get a data file and you just want to try a lot of stuff and understand it and come to terms with it, the web-focused tools are generally less good at that, because they take a lot of upfront effort to build an app, and you don't want that when you're exploring. You want to have quick results, easily try out different hypotheses. And then finally, there's some of these tools are great for small data, or for large data that you've thrown most of it away and just taken an average of everything or binned it real coarsely. And so it's small enough to work with. So those are a lot of tools will support that. But then if you actually want to understand the raw data, you have to understand what you're throwing away when you're aggregating. And so if you're doing exploration, you're always starting with the raw data. So if you have to switch tools when you do raw data versus the final data, again, you're almost certainly going to lose things in the middle. So how do we help here? How does this project help? We're trying to reduce friction and gaps between all of these stages, trying to make everything sort of flow smoothly over the life cycle of a project, over the different uses you make of data and code. Try to make basically life be a little more pleasant and a little easier to get your job done. How do we do that? All of the tools that we looked at all the tools in that chart. We looked at lots of things and say, okay, which tools do we want to focus on? We're focusing on tools that we can use well in a web browser. That means nothing is tied to a specific desktop or operating system's GUI interface. If it only ran on a Mac and couldn't be shared to a cloud environment, that would be very limiting. We need to be able to run these in the cloud, the same as we run them on a Windows machine or a Mac or any other sort of desktop. So everything needs to support web browsers, but we don't want to actually write web browser stuff. We don't want to write JavaScript and CSS directly, or we wouldn't be able to support exploratory analysis. So everything, we want the users to be writing Python. And we want them to write essentially the same code, regardless of whether they're doing a little bit of data that fits directly in the limited memory of a browser tab, or arbitrarily large data that requires a remote cluster, remote supercomputer. Should be the same tools, so that you don't have to make that decision before you start. Because if you start with 1 week's worth of data, what happens a year from now? You've got a year's worth of data. Now it no longer works with that tool. You have to redo everything. That's a bad situation to be in. We want you to safely choose these tools and say, yes, I can use them regardless of the size of my data. And we want it to work in a Jupyter environment, standalone, either. It's the same way. Just basically, if you develop in Jupyter and deploy separately, if you have a gap between development and deployment, you're going to have to rewrite everything. That would strongly discourage you from deployment. And if you can't do that, if you can't share it with other people, you won't be able to make use of it. And unless you can have impact, no one's going to pay for your work. So you want to do something and then share it with somebody who eventually gets something out of it. So last thing, we want to have high-level interfaces, but I'll explain a little bit more about shortcuts versus dead ends later. We want a high-level interface that gets you close to where you're going, but not at a dead end, so that you have to backtrack and then take some other low-level path to get there. So we'll get to that. And then the last thing, this is why we ended up rewriting the entire tutorial this month before SciPy 2021. We really decided to focus around the tools that allow you to exploit the APIs that you already know. So coming into it, we're not going to assume you know fancy features of pandas, but we assume you basically have tried out pandas and you've used a little bit of pandas. We're not going to assume you know anything about Xarray, but if you are an Xarray user, these tools will all work with the Xarray API. And so even though we write really nice APIs, and if you care to, you can learn all about them, we don't want you to have to learn about them in order to get value from these tools. So that's a lot of philosophy and a lot of pontificating, but that's basically what we're trying to do here. And we have a whole bunch of libraries. We are not going to spend a lot of time sorting out which library does which right now. We're just going to focus on the first two and almost entirely on HVplot. So nothing I show today would work without all these other libraries. Ignore them for now. This is our advice of this tutorial. Focus on HVplot today and a little bit of panel when you need it. And then you can bring in other libraries when you need to. They're in the background. They're doing their jobs just fine. You don't have to learn about them and deeply understand them to get your job done. That's the idea. Okay, so we're going to focus on, so the tools that we talked about there are ignoring a lot of things, like the ones that aren't relevant because they require Qt. We're actually also not focused on 3D, so there are ones that are very relevant, but we have very limited support for 3D, so we're ignoring those. And actually, we'll kind of further limit it down. We're really only going to talk about today bokeh, Datashader, pandas, HoloViz. So this little cluster right here, this is the main thing we'll talk about today. Okay, and then where are we headed today? Today we're going to build up the ability to make this dashboard right here. We're going to start in a Jupyter notebook, build up each of the little pieces, and then show you how you link them together and how you add interactive widgets. And by the end of this tutorial, you should be able to write a dashboard like this yourself. This is a dozen lines of code. They shouldn't be difficult conceptually. It's often hard to figure out which dozen lines to write, and that's the point of the tutorial, to help you figure out which dozen lines of code to write. But we'll try to do it in terms of an API you already know, with concepts that we explain one by one. Before we get started on that, we have to introduce the notion of an API. An API, if you're not familiar with that term, is a set of commands by which you access the power of some library. Most libraries for Python will offer one API. Occasionally, they'll offer a sort of high-level API and a low-level API. Like matplotlib offers the high-level pyplot API and the low-level object-oriented API. These are two different sets of commands. You can use either one you want. they have limitations and advantages. And the same is true for these tools. Most of our tools offer one API. Some, like Panel, offers like 6. Maybe that might be too many. HVPlot offers one main API, which is, well, I guess 2 main APIs, one for plotting and one for building apps. So we're going to focus on these 2 APIs. So ignore all the other stuff, all the other ways to do stuff. What we're recommending in this tutorial is follow this approach, and you can get most of your work done and never need anything else. So if you want to learn more later, great. Okay, yes, I'm showing this in Jupyter. This should all work in Jupyter Lab. I'm not personally a Jupyter Lab user, so I'm not demoing in Jupyter Lab because I would probably get confused and not know what to click. But other people on the team use Jupyter Lab every day, so it should. The fact that I'm showing it in Jupyter Classic doesn't mean anything.
In fact, yeah, the binder is running in Jupyter Lab by default, the link I've posted.
Okay, so yeah, if you visit the binder, that'll be the Jupyter Lab version. The Jupyter Lab version has some really cool features that maybe if you're around, Philip, when we're covering those, you could jump in. But for most purposes, they work the same. Okay, that's enough of my talking. Should we run that poll again? Well, yeah, it's probably useful to run it again. Have you now run the setup successfully? Okay, and I'm going to continue on either way. I can't stop now, but it'll help Philip and Jean-Luc have an idea how many people are struggling. So if you, we're going to look at the no answers and just think about those are the people. Oh, we're up to 98%. This is great. Good job, guys. Philip and Jean-Luc have clearly been getting people sorted out. Okay, then I'm going to go ahead and go on. That was the setup and overview. If you're viewing this in a recorded one, this is probably the part you wish you had skipped to instead of listening to me. But, all right, so here I'm starting with O2 plotting. So this is the goal of this one notebook is to take you from somebody who knows how to use pandas to somebody who knows how to use pandas to get an interactive HoloViz-based plot. So you start out with, hopefully, you start out with under your belt some knowledge of Jupyter, some knowledge of pandas, and by the end of this notebook, so a few pages down here, hopefully you're able to use HVPlot and make beautiful plots. And just a little tiny bit of overview. This work is all based on the pandas.plot API. Again, I'm using the word API. Pandas provides an API for plotting, and it's called, so if you have a data frame, you do dataframe.plot. And that API is based on matplotlib. And since that API was written, a lot of other libraries have just copied it or supported it. Xarray is a totally different library other than pandas, but it supports basically the same API. HVPlot supports the same API. Another library called pandas bokeh supports it. Others for Plotly, Cufflink supports it. Plotly Express sort of, it supports a small subset of it, but whatever could be made compatible, they made that compatible. And then PD Vega, I'm not sure if that's, I'm not sure the status of that, but that did support it. I think, but I didn't want to say definitively. So I did not run that. It might be reawakened at any moment. All right, and so here we're going to take, we'll alternate between showing you what you can do with .plot and then show you how .hvplot, if you just substitute that, what you get that's more useful and more powerful. And just as a hint, what it's going to include is all this stuff. You know, I was going to show at the beginning, but it's probably too, we've probably gone too far into it. I was going to show you some examples of running HoloViz apps. I'll just show you one, which is the one, not that one. Well, here's an app. Here's a sort of app. Here's just so you know what an app is and so you know where we're headed. This is an app. You can click on some stuff. It's made with, this particular one is made with Panel, one of the HoloViz projects. There generally are. Here's, whoops, this one is now very big because I made everything else big. This is another panel app. This particular one. If you click on a widget, it'll update the screen. So that's what it means to be an app. An app is some sort of scientific Python code, typically, that updates whenever you change a widget. It'll update that code and then rerun everything. So this particular one is drawing pretty pictures that have to do with physics somehow. Ignore all that. Anyway, hopefully this is making it concrete. That's all. That's basically what I needed to do here, is make sure that you know we're headed to be able to take some code that has some output and control it by widgets. This particular one's not a plot, but over here, these are plots. And we choose widgets, control outputs, to try to help you understand your data. So that's what we're up to. So coming back to it, I have to make this big again. All right, so for these examples, okay, it looks like our final one was 98.8% successful. That's good. Probably never get all the way. So for this example, we're going to look at some data. It happens to be data on earthquakes, but it could literally be any data. In fact, we don't cover it in the tutorial, but it could be things like network graphs. We don't cover that type of data. We do cover multidimensional images. We cover columnar data of various sorts, line plots, scatter points. You'll see some examples of what's covered, but we're only going to cover a tiny fraction of what's supported. We couldn't cover very much in a single tutorial. But what we are trying to really cover well is the process. How do you start with data and end up with a visualization and end up with an app that helps you really understand your data? That's what we are trying to be comprehensive for here. So let's do it. Here we're using pandas. Unlike a lot of the approaches, this works for lots of different libraries. It could be Dask. This is great if you need to work with data larger than your memory, or you need to work on a compute cluster. Pretty much just replace pandas with Dask, and in most cases,
Jim,
that'll go ahead and work. Yes?
Jim, sorry to disturb, but could you turn off your Slack notifications?
I did turn them off.
We can all hear them.
Okay, I need to turn them off on, yeah, so turned them off on my notebook, but how do you turn them off on Slack specifically? It must be going around my browser, I mean, my OS. Well, I'll just go ahead and close it for now. Okay, so I'm not on Slack anymore. So, so if you need me, I'm not there. So sorry about that. Yeah, I was wondering if those were mine. All right, so we could be using, we're using pandas, we could be using Dask, we could also work on GPUs. All these things also support, maybe not all, but in general, it is typically supported to run on GPUs as well. I won't really show that today, even though I've got a very nice HP NVIDIA machine thing right here unused. I probably should have brought that in, worked that in, but nope, it's just using plain pandas so that most people can run it themselves. So of course you need to import pandas, and in this case, we're reading a Parquet file. If you don't know much about Parquet, Parquet is in a columnar format, kind of like CSV. If you can store it in CSV, you can generally store it in Parquet. It usually will be, I don't know, 100 times faster, 1,000 times faster, 1,000 times less space on disk. So it's really a good idea if you have any sizable data that you've got in CSVs, just go ahead and put it in Parquet first. That's what we've done here. It'll make your life a lot better. In this case, we've loaded in a Parquet file. It took 11 seconds on this. I'm running on a MacBook Pro laptop, 16 gigabytes. I think it's about 2 years old. So just so you know what to expect from the performance, that's what is here. This is a 2.1 million row data set.
So just a heads up on the binder. If it crashes for you, make sure you follow the instructions to rename the file. I noticed very late the resources were allocated on Binder are not sufficient to run it on the full data set.
Right, Binder is great at sharing a small thing across a large number of people. That's what it's defined for. it doesn't have as much. It doesn't give much for each user because basically that costs them money. So donate to Binder if you want to change that, but you probably have to be very rich. Anyway, so Binder is a free service, and so it's going to be limited that way. Here we've got 2.1 million rows, and then maybe looks like 25 columns. I printed it right there. So 25 columns, 2.1 million rows. Somebody else can multiply those two together to find out how many data bits there are. But this is a data set, and what it's showing is that on a particular time, at a particular depth, I don't know what that is, kilometers, depth under the surface, including some error measures, at a particular location on the Earth's surface, and with a particular description, like that a human could read, there was an earthquake. And this data set, when we got it, this data set was up to this column, and then we added 2 columns here. We'll talk about those later. We added columns for easting and northing. This helps for display. It basically makes it complicated when you're working with things that are in latitude and longitude, and your screen is not in latitude and longitude. We'll get back to that later. Ignore it if you don't use geodata. You'll never need it. Okay, so that's what's in this data, and we're assuming that you want to understand something about this data. This data could literally be anything that would fit into a table. Here it's indexed by time. It could be indexed by anything. Well, there's a time index and then just a numerical index. Because it's 2.1 million rows, and we're going to work with some tools that do not work that well with larger data like that. We'll make a smaller version that's only 21,000 rows. The tools that we're going to show here work fine on this laptop up to about 1 billion rows. So 1 billion X and Y points are no problem for this laptop. Beyond that, you would want to go to a distributed system, or you could work out of core, but it gets really slow. So if everything you see here, think about, if I've got a laptop like Jim's, roughly I could work with a billion point data set. If you do billion point data sets, you're not going to want to first get rid of most of the rows and just focus on the rows that you care about, just to make, because there's a lot of data here that you probably aren't using very often. Like you don't plot these values. So anyway, this type of data, a couple million rows, it's pretty easy to work with. So you just work with it, and then we'll specifically call it out as a small data frame if we're using a tool that requires it to be small. Okay, so let's go ahead and just plot it. The default, we'll use matplotlib by default. The standard, this comes with pandas always. You can always do this. So this is part of the reason why we recommend that people learn the plot API, because it's going to always be around. It's useful. Lots of different things support it. So we just recommend, if you only learn one API, that's probably a good one to use, because you can use it with lots of backends. You can use it to make plotly plots, bokeh plots, matplotlib plots. It's really just a good starting point. So here's just using the standard inline support from matplotlib. What does that do? Well, it makes a PNG image. The thing I'm dragging around here is just a PNG. It's a picture, and it's a rendered a picture and then displayed it on the screen. And here, this is a scatter plot of X versus Y, so longitude versus latitude. So if you are a geo person, you might be able to look at that and see the shape of Africa. This is actually the edge of that particular continent, I guess. Over here, this is between Africa and Arabian Peninsula, I believe. This is one edge of North and South America, Indonesia, etc. So what this is showing you is that if you plot 21,000 earthquake locations, you can kind of see some aspects of how the Earth is put together. Okay, I had an exercise. When we publish this online, it works a lot better if we use inline, but you can actually use widget. And often that works just fine. Sometimes I found I had to reload the page, but I wasn't quite sure when. But anyway, if you change it to widget and rerun it, that gives you an interactive plot right here. Notice in this particular one, the little zoom symbol has disappeared. I don't know why that is. But if I select that, then I can zoom in on, say, North America. and it will redraw the plot inside this box and so on. So I can keep zooming into things and see that California looks like a dangerous place to be. And you can see, make out the plots. And there's same for, there's panning and stuff. So there's pretty, it's limited interactivity, but it's pretty useful interactivity you can get out of the box. That just does not involve any HoloViz tools whatsoever. Let's go ahead and change that back to inline, since I haven't tested that everything works with the widget backend. Okay, that was an exercise. You can try that on your own. Hopefully it works. We won't spend time on that though. Most of the exercises, we'll pause for just a minute while you try it. And there are two types of exercise. There's these that are inline. I'll be doing a bunch of talking, and then I'll stop and pause for a little exercise. This was the first one, which was very easy. And the other ones will take a bit more work. And then we have separate ones where I finished a notebook and you completely switch into a mode of doing an exercise. I'm not going to talk during that part. That part will be up to you. All right, so here we go. This is the first actual import of a HoloViz tool in this tutorial. 42 minutes in, a new record for how long that took. Okay, so all we did is import hpplot.pandas. hpplot supports lots of different libraries. There's hpplot.xarray, hpplot.dask, lots of different ones. This particular one installs into pandas the support for .hpplot. So now if we take hpplot and do the same plot, we get the same thing we had before. So you can again see the shape of Africa. The only, and also it looks different. It's kind of more integrated into this is a JavaScript-based plot, not just around it the way the widget one was, but inside the plot. And that makes it easy to do things like adding hover. This will tell you the exact latitude and longitude and can tell you other information. So this is from a library called Bokeh that we're building on. Bokeh was originally built at Anaconda a dozen years ago, but now it's maintained by many people across different organizations and not entirely by Anaconda nowadays. But we're building on it, and you can get this plot just as simple as adding that and doing this import. And then we're going to show you how it gives you a lot more power than this. But for the moment, what it did is give you a little nicer styling maybe and some hovering. What you can probably notice is that this plot is a bit ugly, in my opinion, because they're just big blobs where everything is overlapping. See here, you can see there's a whole bunch of points right underneath there. You can't tell how many points are under there. You don't know how many earthquakes were there. 1 million in this point? A dozen? You don't know. Well, we know there can't be 1 million because we're using the small data set and they're only 21,000. But when we plot the entire data set, we really won't know how if you see a big blob. So one thing you can do, so here we're just sort of veering into data visualization tutorial. So let's try to see if we can fix that a little bit. And so here's the standard for the rest of the exercises. There'll be a little section called exercise, and then there's a solution. Don't click on that if you don't want to see the solution. Try it yourself, and then see if you can come up with it. In this case, I'll just show you what I mean. It says try changing the alpha. Okay, well, my guess would be, hopefully this would be your guess too, that you would, because you've got X and Y, you're going to type alpha. But notice that I copied the bit from that example before. So here I am doing the exercise. And so I've told it to compute that. And it's like, oh, okay. Now I can see something, that there are areas where a whole bunch of them are overlapping. And then what it does, alpha controls the opacity. So this particular, this is just one data point. So it'll have a 10% opacity. And then when you get a whole stack of them, a dozen or 2 dozen lined up in a row, then only then do you get fully opaque, blue in this case. So if you enable opacity, you can start to see some structure. You can also change the size. I forget the. Okay, here you can change the size to see. Now you can see a lot of structure. You can see actually we've got a good number of data points. You can kind of make it out. Okay, so you can fiddle with that. Eventually, the thing is that you have to kind of know what you're looking at to know when you've actually captured what's in this data set. If we could fill in more, like this looks suspicious, and so we might tweak the parameters a little bit, but we'll get on to solutions that don't require you to figure it out in advance, that you don't have, where you don't have to look at the data in order to set the parameters, because that's kind of a problem when it's visualizing data you don't know anything about. So next exercise. Oh, and if you click on the solution, I assume it'll show you what I just did. Yeah. Okay. So I won't always go through it right in front of you. I'll give you more time, but I'm trying to give you the idea of what you do. So here, again, we'll take the same example, but it says to try create a hex bin plot. Just as a hint, this was a scatter plot. So hopefully you'll come to some conclusion about how to modify this line to make it not be scatter and make it be hex bin. Give you a moment to actually try that. That's the mid-ocean ridge, I'm told. Not the, it is sure it's the mid-ocean ridge, but it does echo the shape of Africa, but okay. Fair warning, I'm not a geoscientist. We'll see, in fact, in a minute where the edges align with respect to the edge of the continent. So obviously the edge of the continent is just an arbitrary thing where sea level happens to meet it. So in this case, someone on the chat is pointing out that it's actually further beyond where the earthquakes happen. Fair enough. That's the sort of thing you can easily tell using the techniques that we show in a minute. All right, so let's try changing this scatter to a hex bin. Okay, this is a hex bin. Hex bin is a hexagonal binning approach. And this is another way. Here we showed a way that you can, when things were overplotting, like in the original, these are all overplotted. We were showing you how to use alpha and the size to reduce overplotting. Another completely alternative way would be to bin per some all the values in some area, and then use color mapping to show how many earthquakes or earthquake-like events happened in that pixel, in that little bin.
Jim, you lost your screen share.
I lost my screen share. Okay. I reached the limit that I can pontificate. Okay. Better?
Yep.
I didn't do anything. But all right. So these, I'm sure there are settings you can choose to adjust whether the hexes are squashed like this. Obviously, we could make the width be equal, but there's probably another setting too.
Grid size you can adjust.
Grid size, yeah. So just bear in mind, there are tons of options we're not going to cover. And when we get to the first real exercise, we'll look at ways that you can find out which options are available. So I'll postpone that until then. Meanwhile, the idea is here that scatter is not the only type of plot. And in fact, if you use tab completion, you'll see lots of different types of plots. Area, bar, box, a lot. Anyway, that's just an example. Okay, and then actually we're getting right to this. Looks like somebody edited this since I last ran through it. Thank you, Jean-Luc, I believe. All right, so let's say, how would you figure out the options for the thing above? That's what we're covering next. We don't have to waste the exercise anymore. So number one is you can call hvplot.help. You can call just Python's own help on anything. So if you just do help 2, that'll give you a help on an integer object, right? That's help. That's Python's help on anything. So you can always do that. So that's on small if. So you can do Python's help, and generally that will be useful. Sometimes it's going to be overwhelming. It's got a lot of information in it. So let's ignore that for now. hvplot has a special help system, and it's organized by the name of the plot. And so you can do htplot to help for scatter in this case. It's a little more concise and covers things in a nice order. And so this is telling you that the scatter plot, the one that we did up here, so that's help on scatter, offers X and Y. We're already using those. And then a whole bunch of keywords. And so those are generally the ones you're going to need help with. And then there are a whole bunch of options that can be any of the keywords can be any of these things. It's kind of a bunch. And then there are a few other sections we'll get to, Datashader and geography. And then unfortunately, there are all these other ones called style. No, it's fortunate that you have all of these, but this is all the information you have, and I'll show you how to get more information later.
Quick note, can you just hit the hide button at the bottom of your screen? Thanks.
Oh, you can see that too?
Yes.
Well, that's irritating. All right, yeah, I have another monitor, so I have no need for that. Another monitor you can't see. Okay, so if I do, there's some options for HBLE help. If I do style equals true, that's the default that has all of these options here. You can turn those on and off. Turn off basically the different sections. So helping you get onto the specific option that you want. Okay, and then alpha. So here, just as an example, we set the alpha. So you'll notice that alpha is in the option, but it doesn't say what you can set alpha to. Is alpha a Boolean? So the way that I recommend to do it is just try it. Just say alpha equals, yes, I do want alpha. I don't know why that doesn't give you an error. Okay, so it looks like you can, oh, it does accept string for whatever reason. So you have to figure out, sometimes you have to work hard to get to give it an invalid input, depending on how broad the input space that it accepts. But as long as you can figure out how to give an invalid input for that item, then you can use this error output. So what it's telling you is that it does take strings. I don't know what it does with them personally, in various expressions, but generally it'll take a float. And that's not that useful in here. You probably could have guessed that it was going to take a float. But in other cases, it takes one of 7 strings. And how do you know which 7 strings it'll take? You do it like this. Just pass in something that's not valid. Okay. All right. So we're about to have you try stuff. Let's. But first, we have one more concept, I think. Well, hopefully, actually, I don't know how many more concepts. I can't remember. But this is an important concept here. We're going to do something that's supported by this library called Datashader. And you'll notice that this call right here doesn't include any special parameters. And it kind of immediately came back with something that looked like our plot above after we tweaked the alpha and the size parameter. In fact, I'm just going to go ahead and view the full size data set because it's a lot, because what Datashader is designed for you is to use your raw data. It will take all of your data. Certainly any data that'll fit on your machine, but you can pass it in a DAS data frame or GPU data frame. If you've got a beefier machine, it'll take all of your data. And so in this case, what Datashader is doing is actually pretty similar to that hex bin approach above, but instead of having a hex-shaped bin, it has a pixel-shaped bin. So each one of these pixels here is, this particular pixel had 83 points fall into it. This one had 3,000 points fall into it. This one had 600, 500, and so on. And so what Datashader will do with a points plot, or a scatter plot in this case, is aggregate all of the data per pixel and then render that into an array. And the array is what gets sent to your screen. And so this is an important concept, which is basically that if you've got data that's big, rather than try to subsample or aggregate it yourself or do anything that requires an assumption about the data, just feed it all to Datashader. Datashader will render it all to your screen. Datashader is invoked by setting rasterize equals true. That means turn it into a raster, a regular grid. And then now, if you zoom in on it, every time you zoom in, it's updating that grid again. And you can just get all the way down. Eventually, you get down to these individual data points. In fact, you're able to see that the individual data points are on some sort of grid themselves, separated by each other. That's presumably the data was truncated, because obviously an earthquake could happen anywhere on the Earth's surface. It was apparently truncated according to some limited precision. But actually, I've noticed that that's only true in some parts of this data set. So anyway, this is just the raw data, all 2 million points. You can't see individually 2 million points. If you zoom out, they're there, but you can't see them because thousands of them landed in one pixel. But whenever that happens, just zoom into that pixel. You can see them all. And so it gives you, the whole point is that Datashader lets you just dump all of your data onto your screen, and then your brain and your eyeballs can figure it out. And so we didn't have to set the size or the alpha or anything really. We just said rasterize it. Notice here I'm turning on this smooth zoom button here. This is the scroll zoom. Bokeh offers a box zoom. You can use box zoom, and if you have a really big data set, I would use that, because box zoom does one zoom update event. The scroll zoom updates probably 10 times as I did this zoom. You saw it updating live as you do it. Every time it's redrawing, it's having to draw the entire 2 million points again and again and again. So the scroll zoom is convenient, but if it's ever slow, just use the box zoom. So you notice that when I pan, I'll eventually get to the edge of the data set here. That's just where it's not wrapping around at the end of the world. Okay. And here, this is making use of those projection columns I said. The easting and northing columns are what Bokeh is actually using to display. So when you have data that's from the surface of the Earth, you have to project it onto the 2D display somehow. Bokeh by default uses Web Mercator projection. Just ignore that if you're not a geoscientist. Just say this is some flattening of the map onto the screen, and this is the one Bokeh works well for.
Okay, I'll not interject with corrections too often, but in this particular case, we are just plotting the longitude and latitude.
Oh, you're right. I would try to put easting and northing here. Sorry. In fact, let's just see what happens when you mix them. It's going to look the same. So, so here, you're right. I'm jumping ahead of the game. I didn't read that. So longitude. So Bokeh doesn't care if you're just plotting here. When it matters is when you're overlaying these on a geographic map. So we'll get to that. For the moment, Philip is completely correct. We're using the original latitude and longitude values here. And since it's recorded, please do jump in with corrections, because otherwise it'll be on the internet forever. Okay, so anyway, this is kind of a point, and the point here is that HVplot supports this very easy way to just say rasterize it. And notice my hover, I could no longer include any information here very easily other than the latitude and longitude and count, because this has been turned into a fixed size grid that just has the counts per pixel. That's it. So there are special things you can do with Datashader to expose more and more data, and we'll show you some of those. In fact, Jean-Luc's got a talk later at SciPy about exposing lots of things, even though you're doing off-screen rendering. Somebody asked, what's the grid size? The grid size is determined by your screen size. I mean, your viewport size here. So if, it's 1 pixel, it's the size of 1 pixel in this grid here, in this viewport, inside what I'm drawing with my mouse. So if you make a smaller plot, it'll be a smaller grid, and you make the larger plot a larger grid. You can also give it hints and don't tell it not to use all that available resolution. You can, but by default, it's best if you just do it 1 per visible pixel, because then it's the maximum information you can give somebody about your data. You can't do any better than aggregate per visible pixel.
Right. Yes, there's special options that let you kind of just supply a fixed grid size in spatial data units. So you could say, give me 1 pixel per degree longitude.
Yeah, or per degree. Well, that'd be per course.
X sampling and Y sampling.
Yeah, those are additional options here. That if you look at this section called Datashader options in the help, they'll all be there. This is the Datashader option. Just wanted to cover just a brief bit. If I did, notice this color map here is crazy. It starts from 1 and it goes to I don't know, 18,000, something like that. I can never keep track of how many digits there are, but and it's not even regularly spaced. It's roughly log space. So if I do log, it's going to be pretty similar. And here log starts at 1 and goes to the same result, but then it's regularly evenly spaced on a logarithmic axis, so that if you go halfway through here, you can predict what that color of blue was going to have numerically. This is the log option. Log is a great option. If your data is distributed logarithmically in counts, then use a log option. It's great. That's something but that assumes you know that it's distributed that way. EQHist computed it from the data. But I don't know what the distribution is. If the data were linear, it would come up, it would all work the same. It doesn't care what the distribution is. It figures out the distribution. Basically, it does a histogram of the distribution, equalizes the histogram so that each color on this bar here has the same number of points as far as possible. It can't always do that, but it's trying to have just as many of this color as there are of this color, as there are pixels of this color. And the result of that is to show you the most dense regions versus the lightest, the least dense regions, so you can see outliers and trends in the same plot. It's great. There's lots of theory about it. Read datashader.org if you want to know about it. What you shouldn't do is for data like this, you should not use linear. So linear is great because it starts at something, it goes to something, and it's linear in between. That is great for telling a story. But if you look at this data set, it's a horrible color map because you lost all of your detail. You don't know that this area is actually much more dense than this area in earthquakes, because all it is it found the peak, mapped that to this color, the bottom mapped it to this color, and everything, there's nothing in the middle, because most pixels have relatively few earthquakes, and then a few have a whole lot of earthquakes. Those are areas you don't want to buy a house in. We're right over here. So you want to instead use, for many real-world data sets, log will work well. And we recommend always starting out. You probably don't want to publish with this, because you should publish once you understand. But you do want to explore with this. And this is great for understanding, because you can see all sorts of patterns going on here, and then you can try to figure out a good way to communicate that to other people. But first, do this so you understand your data. All right, so time for another exercise, and a short one. And so now let's have you actually do something useful. Select a subset of this data. For instance, things with only magnitudes greater than 5. So let's remember small df. Let's remember where you find the magnitude. It's in the dots. Well, so dot columns. There it is. Okay, so there's a magnitude column. Oops, not column.mag, but okay, so there's a magnitude column. That's a magnitude. Okay, so you're going to try to select the magnitudes greater than 5, and then change the color map. Okay, first let's change the color map, because that's easy. You should be doing this while I'm doing it. Let's see. hvplot.help. We're looking for something to do with color map. I see color bar. Looking for map or color map or something. You probably wouldn't have noticed. There it is. CMap. So you have to know that CMap is color map. It's just the API. Somebody made a choice, and that's the choice.
Color map is also supported.
Well, for those who forget, you can pass color map. Great. But CMap is the official name of this option. And CMap, okay, it's selecting Veritas R. Okay, must be a good one. Okay, so we changed the color map. That part's easy. But now we want to select only the magnitudes greater than 5. So hopefully, somebody's given hints. I knew magnitude is mag. I'm trying to get you to figure it out. So to see that, basically, I'm trying to model the behavior of somebody encountering a data set. I know this data set pretty well, but I'm trying to pretend I don't and say, how would I find out where the magnitude is in the data set? So I look at the dot columns. Other people might have another approach, but well, actually, I look at the head. May as well start with the small one while you're debugging. I look at the head, but in this case, the head hid it inside the dot, dot, dot. All right, so anyway, we're trying to find the magnitudes greater than 5. So we got the mag. We've got the mags, okay. We can find the ones greater than 5. This doesn't get this. You get the Boolean and shows that most of them are not greater than 5. Just to double check that it's working, let's just make sure it's greater than 0. Okay, most of them are greater than 0, but not many of them are greater than 5. Okay, so if you know Pandas syntax, the way you would do that subsetting is okay. Let's double check. We still can't see the mag, so let's just double check the result of that. It's consisting of a bunch of magnitudes greater than 5. And look at that. There it is. The magnitudes are now greater than 5 for everything in that selection. And then all we do is put our plot on it. Okay, there's some chance that'll work. All right. Okay, and then let's try for the bigger one. Okay, so what we've done here is hopefully take a subset of this 2.1 million set of rows and selected only the ones for which the magnitude column was greater than 5 and plotted it with the color map requested. Okay, did we match the solution? We did, except I added this dyne spread thing. This dyne spread is a nice hint for Datashader that when you zoom in enough, the pixels get real big so you can see them. So, how do you get the color bar back? Why don't we have a color bar? That's a good question. Philip, you have any answer to that?
I don't know why it dropped, but I'm pretty sure you can re-enable it with color bar equals true. That looks like a bug to me.
Yeah, I don't know. It tries to put it wherever it's useful. You can always control it yourself, but it should. I would have thought that that would automatically appear there as well. So yeah, add color bar equals true. And the good news and bad news about the dot plot interface is that there are a lot of options. So there's probably an option that you just, when you have a problem, you stuff it in here. And so the bad news about that is if you look at all the options, there are a lot of options to figure out. There's no structure to it. It's a flat list of lots and lots of options. That's the nature of this API. We have other APIs that are hierarchical and nested and perhaps easier to explore in some ways. But the good news is just think of it, and if you can think of the right name for it, find it in the list and put it here, it'll work. Okay, and then very quickly, maybe not that quickly. Okay, somewhat quickly, let's move on and try to finish this so we can have a break. I think we deserve a break before we move on from this. Just something you've already noticed, if anybody has any, shoot, I didn't even show something. Sorry, everybody. There's an index that explains everything, the order that we're supposed to be in. This is the index that we're following through. We did the setup, and then we did the overview, and now we're on the plotting. You'll notice these numbers are totally made up. This is the first time we've ever given most of this material. So we made up these numbers, and we'll revise them later. If we look at the video, we'll be able to see how much time it took. But these are definitely done in an order where we want to spend time and get things done right, because every single thing builds on what we're showing so far. So a lot of times we end up spending more time early, and that's okay because you make it up later because the later ones use exactly what you learned there. So anyway, oh yeah, and if you find actual bugs or issues, please file issues. Someone else As that, yeah, we can't test it on all sorts of every platform available, and we don't try very natural things that somebody would try. So if you find actual bugs, please report them on the GitHub site for the tool that you're using. If you can't figure it out, well, report it on HoloViz GitHub site. That's okay, and we'll figure out which library it goes with. Just put it somewhere. It's easy for us to transfer issues, so don't rack your mind trying to figure out which one it came on. Just report it, put the details of how to reproduce it. That do spend time on that. But if you find a bug, please put a reproducible example on any of our repos, and we'll find it and put it where it goes. And meanwhile, if you want usage help, that does not go in GitHub. We have something called Discourse for that, and there are links to the Discourse site at each of our websites. Anyway, let's go ahead and take all of the, there are a few magnitudes that are less than 0. I don't know why. Somebody who knew this data set really deeply would know that, but let's ignore those for now because those don't make a lot of sense. The opposite of an earthquake. All right, so we're just going to first look at a few different types of plots, and the reason we're doing that is that these plots are going to come up later in the tutorial. So we are not trying to cover all the plot types. There are dozens of plot types. We really can't cover very many. So we're just going to cover a few that are obvious, that are really relevant and important to the rest of the tutorial. First off is the idea of a histogram. Here we're using dot plot. This is not HVplot. This is just dot plot. And so you can see this is a histogram of magnitude. It's a histogram of magnitude. So most events are small in magnitude. There are many, many events that have low magnitude. And a little peek around here, a seismologist would have some idea what this peak means. And then very rare to have very large events. And in fact, that was up here. 2.5 or less was, there are 1 million of those per year. And then it drops with this frequency that you can see here. So, and then rare, the very largest wouldn't even show up in the plot because they're very rare. Okay, so that's how you get a histogram. It's .hist. You do it the same way in HVplot. Here we specified a bin range just to, that basically controls the range on the x-axis of this histogram plot. It's totally optional, but if you want to specify that. Okay, and here, as always with bokeh, you get, when it's used in HVplot, you get default hover behavior. And so the hover will just show you this particular one. Instead of having to read it off the axis, you can just read it out. There are 237,000 counts of earthquake type events with that magnitude range. All right, and there's a little variant. Here's the exercise. This was the hint is that this was a .hist. What do you think how can you get a KDE plot? That would be, KDE plot is an approximation, a continuous approximation to this discrete histogram. So a discrete histogram has bins and says in this bin, count everything. A KDE plot will be a smooth approximation to that histogram. So these options here are specific to a histogram. A KDE doesn't have bins in the same way, and so it doesn't have bin range either. So let's take that off. And then if we just do that, you can have a default histogram. So that's a valid call to hist. But now let's make it be a valid call to KDE. This is KDE. So here you should, somebody was wondering whether the histogram is the same. This is just different binning. They both have 50 bins, but the 50 bins in the bokeh plot are over a different bin range than over the matplotlib. If you line them up right, you should be able to compare them. But bin range, I believe, is extension that's specific to HVplot, so I can just type that in there to see. There are a few things that are HVplot specific, like any of the Datashader options, those are HVplot specific. So if you learn the .plot interface, you should be able to use HVplot. If you learn HVplot and try to use other .plot ones, you'll keep finding things missing. But that's kind of the point of this tutorial. We're trying to give you more power than you had before, things that you can do now with these tools, only learning a tiny bit more. Okay, here we did a KDE plot. Oh, somebody points out if you remove them, they look the same. They won't necessarily be exactly the same. They're pretty close. Yeah, it's got the same little drop of that. So there are little differences between some of the defaults, particularly for this is wrapping a histogram. You have to do explicit aggregation, and there are options for how you do that. So I won't get into that. Okay, categorical variables is just a little thing to demonstrate that this is not specific to numerical values. The histogram is going to histogram across the numerical magnitude value, but you can do a similar histogram for depth. I think that's called depth. And of course, this is a KDE, not a discrete histogram. So here's a KDE of depth. But the depth class is often categorized into 3 ranges, and then it becomes a categorical variable. It's either shallow, intermediate, or deep. So what happens when you have data like that? Well, then we can work with it. Let's see, here we're just, this is what's actually doing that categorization, or that cutting into shallow, intermediate, deep categories. This is pandas commands, nothing specific to HoloViz. We're not going to talk about it further here. If you need to do such cutting, here's how you do it, using pandas.cut. And then we take our new column and put it into our data frame. So here now, this is illustrating another level of power you can have with HVplot, which is to take on the y axis. It says mag here, which is a little confusing, but it's a magnitude histogram. So the y is the amount of histogram. The y is the frequency. So it's a little confusing that it says y equals mag, but that's a little quirk of how histogram is defined here. And in any case, here we're doing histogram of mag, and we're using this new thing that we're introducing here called by. And by is for us doing an overlay. This is 3 different things overlaid on each other. In fact, this is a little live. This legend is live, and so we've got 3 different histograms overlaid to each other, corresponding to 3 different depth class. So by will give you this. It'll give you a plot of a histogram of magnitude by this categorical variable, and then you get this automatic legend behavior. So this is super useful because anytime you're just looking at one thing, it's super easy to just make it be categorical by another and see it. Is this the same distribution? Like these 2 distributions look pretty similar. They both have a peak in the same spot, but you might find that the deep ones, let's see, the deep ones tend to be high in magnitude. We'll actually see that later. And that may not be real. It might just be the deeper they are, the higher the magnitude they have to be for you to detect them. You don't know. This is what the data is showing, but the data is an imperfect measure of reality. So maybe events happen equally at all depths. But here you can see it doesn't look equal. The data is showing a different distribution for that deep class compared to everything else. All right, so the exercise here is to do the same thing, but instead of saying by, to do what's called subplots, and that gives small multiples instead. So let's just go ahead and do this. Very straightforward. We won't need the alpha anymore because that determined whether you could see things through each other. So here, if you take off the alpha, you'll see that it's full alpha, but you can't see anything anymore unless you. Anyway, the alpha was important for the by case, but we're not doing by anymore. We're doing subplot.
To be clear, you're not doing that.
Oh, yeah, we need by still again.
You're still doing by.
You're right. We're doing by, but we're not doing an overlay. We're doing subplots. It would have shown me in 1 second. Okay, so here now we're going to, in fact, I'm going to go ahead and do this special invocation here. We'll get to how this works later, but I just told it to put it all in 1 column. And so now if we look at the deep class, you'll see that that's 1 histogram here, and the intermediate and the shallow. And notice that these are all they're all linked to each other, and they're all in the same scale. And that way, that's why this is so hard to see. You can actually turn that off. Philip, is that frame-wise? Is that what you do here?
Axis-wise.
Axis.
Per axis, if you can think of that.
Per axis.
You're scaling per axis. No.
Okay, I misread that. Okay, axis-wise. So each one of these, this is a set of axes, this is a set of axes, and this is a set of axes. And this option is going to do.
Oh, that might be wrong.
That doesn't look right. So y-axis.
Shared axes false is what you really want.
Shared, yeah, it's a little confusing because we have these nested APIs, and I know the deep API, but not the top level one here. Shared axes. Oh, it's already true though when you turn this one off. Okay, that's an option you could have found yourself in there, but now if we do that, you'll see that you've now got a, you can see all the detail here, but you can no longer compare magnitudes. So now you have to really think about these Y scales. But here, so if you care about the shape, you can really see that the shapes are different in these three cases. And that same thing you could have supplied to this thing as well. Okay, last section. So, by the way, this is all of plotting, all of how to build individual plots like this. So all of the one-line plotting, this is all covered in this one notebook here. So in this case, we're doing, this is showing you that we magically got this little widget here. It's a little crazy, but if you do a group by instead of a by, it will, what it does is the same sort of separate calculation. So that could have been here as well. Call it here. It's probably simpler if I demonstrate that here. So if I just changed by to group by, that's all I did. And it's just, I never can remember, so I always try them both, but one of them does an overlay, and the other one does gives you a little selection to choose which plot you want to see. So basically what it is that it's grouped by this depth class, but instead of trying to cram it all onto your screen, you notice I had to put it in one column and I had to scroll back and forth just to get it on my screen. That's partly because I've made the font big for you guys, but still, very often you can't just cram everything onto the screen and you want to just select it. Because what if there were 50 of these? One per state, let's say. You would want to select it here. So it's a group by automatically knows how to break it down and then gives you a widget to select it. And you can do, you'll get one widget in this case, they'll get more if you need it. Okay. Oh, and then what I skipped over here is I was actually doing that in the context of this bivariate plot. So we did the bivariate plot is like a KDE, but in 2 dimensions. We don't really need to cover that because we're not going to be using that one again, I don't think. And then last thing to cover here is a heat map plot. Here we're doing a double categorical heat map of magnitude class, which is what we did up here, is binned it by magnitude class. This is all pandas stuff. So again, I'm just kind of skipping over the pandas stuff. You do the pandas stuff if you know how to do the pandas stuff. If not, look at the pandas docs. We're just going to assume you're going to use pandas at whatever level you're comfortable with. That's what we assume. And then we'll show you how to do the plotting. So here we're using, instead of .scatter, we're using .heatmap. And yes, Philip, I don't think, is by in the original API?
Neither by nor group by
nor
are.
subplots, nor group by. Yeah, so all of the stuff I've been showing you recently is all, in fact, the whole point of this notebook is to show you what you can do with HP plot that you couldn't do with .plot. So we show a little bit of .plot, but most of these other things are unique to the HP plot interface. So, all right, in any case, here we, instead of .scatter, we're using .heatmap, and we're doing heat map by magnitude class, which we just created, versus depth class of over there. And then what did we use for coloring? What is ID? I don't know what the, oh, it's, so it's adding the, Bill, what is ID?
Oh, this is just kind of a trick.
Okay.
We've basically done a count, and here we're just doing the count. Basically, it's just counts per bin.
Yeah, what are they called ID?
It's a very good question.
Anyway.
There's no good answer.
There's no good answer. Okay, so anyway, it is a heat map, and these are counts. This is the color map for the counts, and this is a couple of events. So there are very few great deep ones, and then there are very many minor shallow ones. So this is the by far the most common things that you would hear about that that are recorded. These might be the ones that you hear about, and then these are rare. Okay. All right, now that is approximately an hour. So we did about half an hour of intro and covering various things, and then spent about an hour on this notebook. So if we're editing that label later, we need to either speed this up or write down 60 minutes on this notebook in the index. The next one is actually very, very short, but I will still take a break for about 5 minutes here. You can actually open up, while I do that, it's worth, unless you need a break, this is, so in 5, I will return at 3:33 my time, which is in 5 minutes. And so during that time, you can either be starting off exercise 1 or take your own break. And we'll have a bigger break after the exercise. But exercise 1 is going to cover material from both notebooks 2 and 3. You can already get to start on it using just notebook 2. It's not till the last cell that it depends on notebook 3. Okay, so I will stop speaking so you can start thinking, and so you can head to the bathroom, whatever you need to do now. I'll come back in 5 minutes. All right. Well, that's been 5 minutes. We'll have a longer break in a minute after we get this next section, but I just need to catch my breath for obvious reasons. Figured you probably did as well. All right, so you can come back to that exercise in just a minute. We'll have the next one, the exercise and break, are combined together. So there's a good bit of working on your own and getting help from us. But before we get there, I wanted to tell you one more thing. So we've shown you how to get plots, and you can use the help that we showed there and various other ways. You'll soon end up with lots of plots. And what we're going to tell you now is what to deal with, how to deal with having lots of plots. Like, how do you collect them and do something, tell a story with them and understand how they relate to each other. And this part is going to take some, it's not much material, but there are some ideas in this one, so bear with me. So we'll just, this is a totally independent notebook, so it doesn't know anything about what we did in the other notebook. So we're starting fresh. All we're going to do is read in the data and then import hvplot.pandas. Before we do anything, we're going to take this data that could occur at any time of day and resample it at a weekly level. You can do whatever you like. It's just useful for this particular set of plots. Nothing depends on that. It just makes it easy to look at various things. So here, let's see. We're looking at the total, the events, basically, the counts per week. So there's a really dangerous week here, it looks like, in 2008. A whole bunch of things happened. But that could be for many reasons. This is how this data is recorded and reported varies. Like, those might be a bunch of small events happen. So never take anything at face value here. This is just a this is a way to get a plot, and then now is when you have to take a deep breath. Notice what we did here is we did .hvplot. If you did .plot, I don't even know if that'll work. It does work. Notice that you got a plot in this case when I did .plot. Now, how did that happen? Because I took a variable and assigned something to it, or an attribute, a Python attribute, and I have another one and assigned something to it. So this is what's called a side effect. Executing this line had a side effect of displaying this PNG image. And that's just how the matplotlib inline interface works. It could be designed differently, and there actually has been changed in some ways. But anyway, the default is that that you run some code, and as a side effect, you get this plot. But you notice if you do it with hvplot, there's no side effect. You just assign to this value, and until you look at the value, and look at the value here in Jupyter means it is the result of the expression on the last code line of the cell. So you could have lots of other things in this cell, like some numbers and some strings, but you're going to get the plot if it's the last one, and if it is not the last one, you will get whatever the last one is. Hopefully that makes sense. What that means is that hvplot works just like everything you're ever used to, except for .plot. .plot was the weird one because it was unusual to have it work as a side effect. Normally, if you just typed the number 2 in a cell, you wouldn't expect to see the 2 output from the cell because that's not the result of the cell. Jupyter just defines the result of a cell as being the final expression of that cell. And so hvplot is designed to make use of that. And so what that means is that you can easily grab a hold of your plot and do stuff with it before or instead of displaying anything. In fact, you don't need to display it at all. You could just get the data that's in it. And I'll explain how that works in just a second. So, or we could print it. Printing it will tell you what it sort of tells you what it is. It tells us because we know what this means. And what this is a representation for what's called a HoloViz object. We've been talking about hvplot all this time, we did not explain what the HV was. Of course, the H was holo from HoloViz, but the V doesn't actually stand for HoloViz. It stands for HoloViews. HV plot is a version of .plot that returns HoloViews objects. And you can learn all about holoviews.org if you want to. If you go to holoviews.org, you can listen about all our philosophies and how we designed our beautiful API. But you can ignore that. And you probably ought to look at some of the galleries and see what's available, but not during this tutorial. For this tutorial, what you need to know is that when you invoke HVplot on your pandas data frame, what you get back is a HoloViews object. And knowing that is actually going to open up all sorts of things you can do with these objects later. We're only going to do a few of them, but you're not just, as a side effect, making an image appear on your screen. You're getting an object that you can work with. And this particular object is a curve indexed by time and reporting count. Here, time is the x-axis, and because the curve plot has an x-axis and a y-plot, other kinds of plots have other axes. This one has an x-axis and a y-axis. And on the y-axis, it's reporting count. And this little bracket here means that this is an independent dimension. It is count as a function of time. It's not time as a function of count. Like the world's time does not increase the more earthquake events happen. It's the other way around. As time goes on, time is going to go on regardless, and either you measure a count or you do not, but the time is independent of the count. So in this case, this is an independent dimension. Typically that will be mapped to x on an xy plot. That's why it is showing up here. And then the count is dependent on the time, so it's a count per time, and then that shows up on y. And if you look at the result of any HVplot call, you'll be able to see what the type of the thing that you got back is. And typically it will be a HoloViews object. There are cases where it's not, and I would like to remove those because sometimes we have to go beyond what HoloViews could do. Those are usually when you get special types of widgets that HoloViews can't handle. Anyway, most of the time you're going to get back a HoloViews object. And as soon as you do, you can work with it. So let's get another HoloViews object. Here's one that's showing the mean magnitude. The other one is showing the count. So now we've got a weekly mean magnitude and the count. Let's look at the mean magnitude. Oh, it's also indexed by time, but instead of the count, it's magnitude on the y-axis. Also a curve. And then now is when we make use of the fact that it's a HoloViews object. A HoloViews object supports two major important operations. One is star. If you take one HoloViews object and star the other, it's going to take the first one and put the second one on top of it. So it's called an overlay, and this is an overlay of the mag and count. So they share the same time dimension, but the y-axis is either magnitude or count, depending. And so anytime you get something from HVplot, you can always you can attempt to overlay it. In this case, it doesn't make much sense to overlay because you're going to look at it and say, well, shoot, this one is a big, complicated histogram. This one's a flat line. And if you scroll back, you can see why that is. The magnitude is between 1 and 5-ish, or 3-ish, and the count is between 0 and 9,000. So you plot those on the same axes, they're not very useful. So this is actually not very useful. So let's skip on to the next operator. But I wanted to show you because you often want one or the other. You either want to take two objects and put them on top of each other, or you want to put them next to each other. Next to each other is plus. So if we do plus, we get two plots laid out next to each other. This is called a layout. This one is called an overlay. And in fact, if we print that, it'll tell you that it's a layout. It in fact is a layout of two curves. This is actually how you can actually index into it and get your original ones. I don't know how much I need to cover. Well, this is getting into HoloViews, but basically HoloViews give you some objects and you can put them together. You can also take them apart later. So if you have some big complicated thing, you can always pull out one bit of it and rearrange it and do all sorts of things. It's part of a principle we'll get to the end at the end of this thing called shortcuts and not dead ends, which is you can always keep going. Here, just like I showed with .data, you can actually get at the underlying data. You can also, because you've got the underlying data, you can overlay them. You can put them in layouts. You can do lots of things here. Let's add an additional dimension. I can't remember why, but we'll get to it in a second. We're just demonstrating more things that we can do for the moment, but there's a reason why this comes together, but I've just forgotten it. In this case, let's take our scatter plot and add color mapping of the points. Here we're going to color by magnitude according to this scale. Note that this is just regular dot plot, and we're only looking at the most severe ones at the moment. So we'll do the same thing. And then if we didn't have that, we wouldn't get anything printed. But we do, so we're going to see the plot. So now it's coloring by this. You could instead CMAP equals gray, or it's grays. I think it is. Yeah, CMAP equals grays to have the comparable plot. Okay, and then we can look at that and now see that this is actually illustrating something. Now I remember why we're showing this. I knew there was going to be a reason, and the reason is that this looks like a plot, and this is what you get from dot plot. Yeah, it's a plot of latitude and longitude and magnitude. Latitude, longitude, and then magnitudes on the Z dimension, the color dimension coming out of your screen. You can't see it. This is X dimension, Y dimension, and the other dimension is color, according to this map. But if we look at this object, we'll see a problem. Look at the HoloViz representation for this object. It has a scatter plot of one independent dimension longitude, and then two dependent dimensions latitude and magnitude. That makes no sense. The latitude is not a function of the longitude. It is, the way these plots were obtained is that there is a position on the Earth, and at that position there was a magnitude. This should be a plot of latitude, longitude. It's the magnitude for latitude and longitude. This is probably going to confuse people, but I'm going to do it anyway. So this is the reason that this is happening is we're getting the wrong HoloViz object out of here. And the reason is because we're using dot scatter. And dot scatter is meant for when you're choosing a one-dimensional X position, like say the length, and at that X position you measure, say, temperature. So if you've got a bar and you're measuring the temperature along different points of the bar, you'd choose a length and you'd measure a temperature. That's what a scatter plot should be. And here we're abusing it to show a set of points. These are two-dimensional points, latitude and longitude. Latitude and longitude, neither one is subservient to the other. They're both independent variables. So HoloViz HV plot offers a dot points object that is exactly the same as scatter, but it doesn't. It's saying it's a plot of latitude and longitude as independent dimensions, and then magnitude as the dependent dimension. So this is this is something we can work with now because it is correctly indexing the data. There are a lot of cases that are very subtle and they're very weird, and you see them later and it's like, oh man, I should have declared correctly that this is the right set of independent dimensions. And unfortunately, I don't have an example to show you now. We should definitely add that, as I'm looking, Philip, to show you a case where it really matters. At the moment, they look the same. If I put it back to the same color map anyway. The plots look the same, but this is a plot that is correctly declaring that this is a magnitude per latitude and longitude plot instead of a completely nonsensical latitude and magnitude per longitude plot. Okay, so the side completed. That's just the reason I'm showing you that is the only reason I'm showing you that is number one, it's true. Number two, we're going to use points in the rest of the tutorial. So if you're trying to remember points versus scatter, just use points if you're talking about points. If you're talking about a two-dimensional point, and that's the thing that you're going to be reporting a measurement about. So anyway, that's an aside. It is important for HoloViz. As long as you're happy with your plot, it's fine. Okay, let's do another little bit here. So we can get you ready for the practice of the exercise. Here we're going to need to choose a different color map because the problem with this color map is that we want to overlay on top of a map. And a map is full of oceans, and oceans are blue. So we need some colors that do not match the color of the map we're going to use. I'll show you the color of the map we're using later, but believe me, it has lots of blues in it, so we can't use this blues color map. So let's find another color map. We're going to use a HoloViz library called Color Set. We happen to pick this particular color map from it. In fact, we'll show lots of them in a minute. But we picked this one because it is very different from oceans and does not contain white. So if you overlay something on a white background, you don't lose any points. So it starts at black, but it does not go all the way to white. It just goes to bright yellow. And we're going to switch it around so that, because we're using a white background for a lot of these plots, we need colors that at the bottom of the color map are similar to white, but are clearly different. That's what, and then get more and more different from white. Just look at the contrast along this edge. This has a low contrast, and it gets more and more high contrast until the darkest points are high contrast from the background. This edge is very high contrast. This edge is low contrast. That's what we want. If we have a white background, we want a low contrast here, a high contrast here, so that strong values pop out as being very different from the background. So this is a good color map. It doesn't match oceans, and it's oriented the right way around. We just did a little Python trick to flip you can do this on any list, and the color map is a list. It's a list of colors, typically 256 of them, and then you just tell it to go in reverse. It's a -1 stride. We're going to add a little bit more information to the hover in this case. So now if you look at the hover, you see it used to only say latitude and longitude. Here we added additional hover columns for place and time. And now when we hover, you will see the place in a human readable form and the time of the event. So that's just useful. And then now if we're looking at the representation for this plot, you should always be going back and forth between, you got a plot, you should look at it and see, is it a plot of what I think that it's supposed to be a plot of? It's very useful to look at this representation and think, do I understand this representation? In this case, it's a plot indexed by latitude and longitude. Yes, that is what I wanted to do. And what's in the plot? It's got magnitude, place, and time. Now that might be confusing. This is a plot with just magnitude, right? No, you can have lots of different what are called value dimensions. You can have as many as you want here. And right now, those value dimensions might or might not be mapped to a plot, but in this case, they're mapped to the hover. So the place and time are there. They're in the plot. They're available for the plot to be rendering if it chose to. So like you could map the time to some other variable, like the orientation of a line, if you have little line segments or something. I don't know. There are other ways you could map it onto the screen, but even if you didn't, we included it in there because we want to map it onto the hover information. So hopefully that makes sense. It'll probably make sense if you go over it, though. And then we're trying to overlay it with some data and show how this all fits together. So that's where we're heading. And so we won't spend much time here, but just show you the output of this exercise. I didn't input. It's weird. I must have skipped a cell somewhere deep in the back. Either that or it's missing in there. Sorry. I just cut and pasted it. I also have to import it. So from color set, import. I think it's in the plotting library. Okay, so yeah, it wasn't imported because we hadn't previously used it, but now we have to import it. What this does is just plot all the color maps available in color set, and that's these might come in handy for your own exercise. That's why we did that here. You can look at all of these and choose anything you want, and some of them have multiple aliases. Like this one is called gray with an A, not an E, and it could also be called this. That's a different indexing scheme, and then this tells you how it was created. So you can ignore the long ones if there's a short one. Just use the short one. It's fine. Gray or dim gray. Dim gray doesn't go all the way to white. Like I said before, that can be very important. This gray goes all the way to white, and you'll see there's a tiny little gray line that distinguishes these two, but you wouldn't use this if you're on a white background. It would cause you all sorts of trouble. But it's fine on black. Dim gray you can use against white. So these are useful. Choose whatever color map you want. These are all what's called perceptually uniform. That means they aren't going to lie to you about your data. A certain distance in this space it corresponds to the same distance in your value space. If you're plotting something, it's going to look as different on the screen as it is in the data. So those are, I wouldn't ever use anything that's not perceptually uniform unless you know what you're doing. These are all a good collection of uniform ones. Viridis is another one. There are various ones with Matplotlib, Plasma. Okay, now, like I said, we're going to be overlaying on some geographic information. So in this case, as promised, this is a geo plot that includes a whole lot of blue, so not appropriate for other color map. We put data against it. This particular one is from OpenStreetMap. It's an open collection of geographic data. And what this is a web tile service. The way that works is you're probably familiar with from Google Maps. If you zoom in, every time you zoom in, it renders at a low resolution, then it updates. It's quite like Datashader. Datashader does not use tiled maps, but this is like Datashader in that you zoom in and it makes a request to a server, and the server gives you the more detailed information. You can keep zooming in. At some point, it'll tap out, like around there. No, I guess it keeps going a little more. Maybe this one's defined never to tap out. I don't know. Most of them will tap out and it'll say no further detail available. Okay, so that's a very useful thing because you can put things in geographic context. And like I said prematurely before, since I was not in fact using projection yet, you need to project from latitude and longitude into this coordinate system, which is, as you can see, it's a box. The shape of this box is using the Webb Mercator projection. So it takes the round Earth and cuts it and then stretches it into this shape. That's what a projection does. And to do that with the, and you'll notice that it's not uniform along the latitude or the longitude dimensions. I guess it's uniform this way. It's not uniform on the latitude dimension, so that the first 20 degrees of latitude take this much space on the screen, and the last ones up to 80 take this much. And then down here, they didn't even render all the way to the bottom of Antarctica or the top of the world, and that's because it blows up. So you're taking a sphere and mapping it onto the screen. Ignore all that if you're not geo interested, and just trust us. We projected it. There's this function here you can use it to. It creates easting and northing out of latitude and longitude. So we already did that, because it takes a little time to do that. We did that so you don't have to do it every time you run the notebook. And now we can take our data, and you can see now it's nicely high contrast against the map. And what we did is take this thing here, using the technique we already showed you with star, and did OSM to get a map like that. That's a constructor, so it makes a new OSM map. And then use overlay, and then we're plotting, doing a points plot of the most severe earthquakes using this color map. Okay, and that's the one we selected right there. All right, so now we're showing the data in context, which is useful. And particularly because you can see that here, yes, they do in fact follow the edge of North and South America. The Africa ones must be in between here, but there aren't enough severe ones. Those are quite deep.
Yeah, we had people point out to us it was the North Atlantic Ridge.
So somewhere in there, not marked on this map. In fact, there's probably a tile map you could have that has the North Atlantic Ridge nicely marked, and we could see them lined up, although this is only the most severe ones. Anyway, this one is not doing a lot of detail in the oceans, but there's probably one that would, and we could see how those mapped up in the oceans. But we can certainly see that they do map up, so they've been correctly projected. It's probably a pretty big coincidence otherwise for having them match up the edge of these continents. All right, in the spirit of HPplot, which is make everything an argument, tiled maps are also an argument, so you don't have to learn about what we just talked about. But you do need it in general. We'll need to be overlaying things in general. So there was a point to presenting it, but here you can just do simply this. If you want tiles underneath it and your data's already been projected, just do tiles equals and then the name. This is OpenStreetMap. There are lots of them. And some of them are irritating because you can develop with them, and as soon as you try to share it on the web, they block your requests. So OpenStreetMap, I believe, doesn't do that. Wikipedia does, even though it's an open system too. All right, import and use different tiles. Well, you don't even have to import them if you do it this way. But
I don't know if we want to speed things along a little bit instead of.
Yeah, probably should skip that. That's a good idea. So there we go. So anyway, that's an exercise you can do on your own. This is important though. Well, that's important, but let's just treat those tiles as being good enough. This is important. Here we're going to show you a very specific a completely different type of data. This is not a pandas data set. This is an X-array data set. Well, I shouldn't say that word because data set has a specific meaning in X-ray. It's actually an X-array data array, not an X-array data set. And this is it's an array of by X, Y, and band, where the value is, so the coordinates are X, Y, and band. These are all corresponding to like our key dimensions. And then we can go ahead and plot this. In this case, we can use the dot plot, just as usual. And what we're doing is, this is the X-array dot plot. So this is not HV plot, this is not pandas. It is X-array copying the pandas array API. And this is one of the reasons we said it's useful to learn that API, is that you can go ahead and, when you need to use data that's not columnar, that it's not well suited to a table, this is data that's two-dimensional. It's indexed in X and Y, and on a regular grid. So it's called gridded data, or indie array data, or multidimensional data. In this case, we took a tiny little slice of it. If we took off this little select here, this X-array select call, it would try to plot the whole world, and this would not work very well. It's very slow. But if you're using Datashader, it's not slow. So we'll just switch to Datashader now. Switch to HV plot. So here we can easily plot. You saw that that came up quite quickly. That's HV plot calling Datashader using rasterize equals true. C norm can be whatever you like. So now we have a plot of the population of the world rasterized per pixel. So nobody lives in the middle of the ocean. A lot of people live on the coasts. People live on this coast, and so on. A lot of people live in India. This much is very clear. And it's a logarithmic scale, because if you did not, you have the usual problem that there's some peaks in India, peak in New York, LA. This is the population density peak. There are a few peaks around the world, but mostly you would see you see almost nothing unless you do a different transformation. Okay, so we use that, and then now we get another thing that'll hurt your brain. You would expect that this would be a HoloViz type image plot, because you did a dot image. Previously, if we did a dot points, you got a HoloViz points plot. You did a dot scatter, you got a HoloViz scatter plot. You'd expect to get a HoloViz image plot here. But in fact, you get a dynamic map of images. What that means is an image indexed on some other dimension, dynamically choosing some value across that dimension, which in this case has no value. It's actually indexed by the zooming in ranges, but I won't get into that. Anyway, it's something called a dynamic map, and that's a HoloViz concept, and that'll be true even if you had the, shoot, it'll be up here. You can, if you had Datashader rasterize equals true, and then print the type there. Again, it's a dynamic map. So whenever you type rasterize equals true, a lot of magic happens, and you get a dynamic plot that is automatically updated all the time. Each particular thing that you get is a normal HoloViz image that could have been, oh, actually, notice, it turned it from a points plot to an image plot. That's literally what rasterize does. Rasterize turns a point plot to an image plot, and it's a dynamic image plot. You can actually, just to keep the digressions going.
Yeah, just a quick reminder, Jim, we are running low on time.
All right. So, I know. Okay. This is the important stuff, though. Okay, then we get to the back. Oh, we probably don't need to cover that. Don't need to worry about that. But you should come back and try out anything I skipped. Now let's actually just take those things and overlay them. So this is the overlay operator. We take the rasterized population. That goes in the background. We change the color map for whatever reason. And then we overlaid the highest magnitude events. We relabeled it with a title. That's a new concept, relabel, but that's how you change the title. And And then we get this plot. This is the plot that we're going to use in later parts of the tutorial. And we can look at that. And this is what we got. We got a dynamic map that is an overlay of an image plot and a points plot. The image plot is a plot of X and Y for population. That should probably say longitude and latitude.
It's just using the variables in the data set, in the X-ray data set.
Yeah.
Which were called X and Y.
They happen to be called X and Y. These came from two different sources. They're entirely different sets of data. So probably we would want to read and label those original ones, latitude and longitude, just so it's not confusing. But anyway, it doesn't matter. They are in fact plotted on X and Y, so it's fine. Okay, and then you can study this diagram later. All it is making the point that you did not get a dead end from any of your plots. You're always able to keep working, and you can access data on them, or put them together, overlay them, lay them out, and do more and more. And just the whole rest of this tutorial is you doing more and more. Starting now, the next part is, whoops, I just closed the index. Let me get it back. And then take an exercise. So you already probably started on the exercise. Keep going. We won't take you through it specifically, but whenever people raise things in the chat, we'll just talk about it if it seems relevant to everybody else. So I'll run through the first step of this just so we're all at the same point. All we've done is gotten the same data we were just showing, including the raster. And now we'll do here basically what we just did on the previous notebook. So you'll fill that in. And remember, there's always solutions, but try not to use them until you really are hitting your head against the wall. And then when you do use them, try to figure out, oh, how would I have figured that out? And if it's not clear, ask us on the chat. Okay, and then basically just follow the instructions. They're solutions, but hopefully don't use them too quick. And then when you get to the end, this is the only part that depends on this last section that we just covered. So it's 4:06 my time. We already spent some time on that, so let's spend 10 minutes on this, and then wait for 15 minutes total. So that'll be back at 20 minutes. After.
Sorry, aren't we done in 25 minutes?
No, just till 6.
Oh, okay.
My time. So we're done in 1 hour, 55 minutes.
Yes, I was confused. Wait,
So,
an
yeah,
hour?
Just go ahead.
Oh, never mind.
Okay, and then this is so the whole point of this part here is to get practice doing plotting, and that's super important. There's going to be another section. If you don't, we're going to skip through that pretty quickly. If you don't get those, that's not nearly as important as what you're doing right now. And then we're going to get to another section that is also very important. So right now, this is a break. This is really important stuff we just covered. Please try it out. If you can't get it to work at all, please chime in. We're here to help you over the next 15 minutes. So don't think you'll come. There'll be great stuff soon. There is great stuff, but none of it will work unless you figure out this stuff right here. So chime in with questions if you have them. If not, I'm going to be working through this tutorial on the screen, so watch that if you want, or do it on yours. that? I don't know what that is. I'm going to ignore whatever that is. It's not my phone. All right, I finished early, but I kind of know how to do it, so not too surprising. Oh, share screen again. Maybe that's what it's. Maybe that what that noise might have been is representing share screen. So all I was doing is I worked through the tutorial and made a blues color map version and figured out that markers was quote cross, and then overlaid them. Someone asks quick points.ops tools equals tap. This is a tap tool here, also called hover. Well, no, that's a hover tool. There's a tap tool where you tap on it, and the tap tool is if you do a click. So it adds a tool, but I don't know where that came up. Anyway, I would use a tap tool if I wanted to have a click here, launch another plot. So you can learn more about the various tools at holoviz.org. All right, I think, oh yeah, this is meant to be break time, so never mind. I won't start again. My screen share dropped. Okay. Someone asked, can we plot a map of the Earth on the sphere in 3D? You can, and see geoviews.org. GeoViews is basically HoloViews extended to have all sorts of crazy projections. It handles all the projections for you automatically. What it doesn't do is, so it'll definitely do a projection where this data can be shown in a sphere. What it doesn't do is 3D rotating spheres. It's just it's a sphere projected onto your screen, and it also doesn't do web tiles where you zoom in and each bit of the sphere is increased in resolution. It's this, except for how Datashader works. So it won't be like Google Maps on a sphere. So basically, it doesn't support Google Earth at this moment. So nothing exactly like Google Earth, but it's roughly like Google Maps. It is supported, and a rendering that looks like Google Earth is also supported. But this tutorial is not focused on geographic applications. I'm assuming that sometimes you want to show data on a map, and that's useful, but this is not a geographic tutorial. There's lots of support and technology for that. We're not going deep into that. For that, see geoviews.org. Or the htplot geo section, I think it is. Yeah, see that section. We're going to do very little of it. Notice what happens if you do these in the wrong order. Here I put the red points behind the population data, which means they never obscure the population data, but they often do obscure the point. So you get to choose what goes in front of what. And you can set your alpha to make it transparent or whatever. But it matters what order you put these in. All right, we're gearing up. In 2 minutes, we'll start with the next set of next section. This is the first one. It says 20 minutes. I'm not going to spend 20 minutes on this first one. I'm just going to show you basics, but it does take 20 minutes to really get into. So I'm going to show you just the final result of it. Your job later will be to study it. And if you think it's interesting, please follow up on it. I think it's important, but it's not as many new concepts here, and it's just something that we'll use. The fact that it works, we'll use it in the later tutorials. So I'll start out here. I'm starting officially in 1 more minute so that people who left could come back as promised, but I'll get ready. So I'll read it in. Whoops. Mercer. Okay, that's all ready. Okay, I've pre-run it, and I'll start again in a few seconds. Time clicks over. All right. Okay, so we're now on section 4 of the tutorial. So starting at the top here, we did set up an overview. We went through plotting. It did not take 30 minutes. It took an hour. Overview took, it's supposed to be 15, probably took 30. So we spent 30 minutes here. We spent an hour on plotting, a little bit on composing plots, and we finished exercise 1. And hopefully people got some things to work. And probably what you found is that there are things that you could figure out and they were relatively easy, and then there are other things like, I know you can do that. How do you do it? And that is the hard thing. It's we showed how to access the help, how to go through it. After you work with it a while, you'll get better at finding the information you need. So that is something that you'll just have to get practice on. So often you won't find it, and then you look further and you'll find it. So that's something that we can't cover in this tutorial today. You're just going to have to try it and get used to the ways that you find out information about it. And obviously you can find out, go on their website, go find if you go to HBAPlot, you can find other examples and copy examples. That's usually the hard thing, is to figure out the easy way to do it. So that's definitely something to practice, to try stuff and just see how they go and figure it out. Now we're moving on to the building interactivity section. That was the end of plotting. And now we're going to start to do, we're trying to add more and more custom levels of interactivity beyond just having a plot. And as you saw, they were already very interactive, but we're going to add more. We're going to make them more interactive, and then more custom, and then more custom interactive, in order for you to really figure out what your data is doing and how to understand everything. So first off, we do something that's in code is very easy, and then it's going to take a bit to explain the concept. So all we do is we read in the data. We're looking at the most severe ones just to make it really easy. Small number of data points, easy to figure out what it is. We're going to make a couple of histograms. And if we just did this, we'd get a plot just like this without this LS. So I'll come back to that in a minute. And this is just 2 histograms of either depth or magnitude, just like we saw before. So, and they're combined with plus, so you get a layout. So far, so good. Now, what is this LS thing? It does not mean Unix list directory commands. It's referring to this. It stands for link selections. And what we did is link selections is a sort of fancy function that you can call on a HoloViz object. In this case, we got a handle to it by calling .instance. This is irritating that we have to do this, but what it does is this object is going to represent a set of selections that cross across different plots. And so how this works here is if we take this this little selection tool here, I'm going to select a section of this magnitude plot. Well, let's just actually let me reset that. Let's select the very deep earthquakes. What I did is I selected from here to here. I used this little selection tool in this plot, and that that information about what I selected here went back to this linked selections object, and then it replayed this plot to show the subset of all of the magnitude, all of the earthquakes that were very deep. And so it's showing you that there were 7 of the low magnitude ones that were very deep. There were 6 of the medium magnitude, and so on. So these are all in context of the whole data. So the whole data is grayed out and in the background here, and then the selected data is now visible on top of the entire distribution. So what we've done here is we made a selection in one plot to answer a question: how does depth relate to magnitude? And it looks like it's kind of distributed across there. What about the other way? What if we did the low depths? Okay, the low depths seem like they're pretty much, well, for one thing, it's most of the distribution. But anyway, we can try to see how these things relate to each other, and in fact they can go backwards. Give me all the ones with a low depth and a high magnitude. So now these are linked selections in both directions. So what I've done here is take some data. In the preceding tutorial, we just figured out how to get the data on your screen and get it to be normalized together, get it to be, it was already linked together in the sense of, well, actually they don't share an axis, so they're not linked together. But anyway, if they did share axes, they would be linked. Now we're linking them by selections. So when I do a selection on one, it's showing me all the ones in this magnitude range that are in this depth range, and so it's different from the full distributions. And here it's showing all the ones in this depth range, limited to the ones in that magnitude range. This probably doesn't make any sense, and I figured out how to write it so that I would hopefully make sense. So let me try here what I wrote, because if I don't follow it, I will get confused. So if I select the deepest ones, they are, I wrote that it doesn't have much relation, but there are times later in the tutorial where you can very clearly see a relation. Anyway, basically what it does is, your job is to get plots that show various views of some data. This is depth and magnitude. Those are different columns in the field, different columns in the data, but you can see how they relate to each other. In this case, they're pretty much not terribly related to each other. Well, actually, what if we select here the deepest magnitudes? Okay, well that's a little clearer. In fact, let's zoom in here. So we can see a little more detail. There we go. Unfortunately, I selected again. Anyway, maybe I'll just skip on from there. But basically, the idea is that what we've done is be able to relate any aspect of your data on any plot to any other aspect of the data shown in another plot. I realize I'm not explaining this very well. You're probably going to have to go to the website about linked selections. That's at holoviews.org. There's a user guide. All of that. It'll make a lot more sense than I'm currently making. So that's under user guide. It's called link regression. So going back to it, I think it'll come up more naturally in other examples later on here, and it'll probably make more sense. Let me just move on. It will eventually make sense. Oh, okay. Here's where I had the example here. This is the example that makes sense and that I can actually explain, because the problem is those distributions were pretty similar to each other, so there was no clear distinction. But here I found that if you select just the earthquakes in Alaska, so here's Alaska. If I select just those, there are almost none of them that are not over here. Now that could be that there are very few in general at high depths, but it is also true that it could have been that they were all found at high depths. They are not. They typically are found shallow. So that's what happens when I did a linked selection between this points plots. So I'm selecting by geographic region, but then I'm comparing it by some other value, the depth. So I hope that makes more sense, and you can do the same again. So let me reset my plot so I get it all. Oh, that mixes it up. Unfortunately, that's a bug that Philip and John were looking at earlier. That it's stretching the geographic plot to match the size of the data that's available, which is not very pretty. So that should not be happening there. So in that case, I'm just going to rerun the cell. So that's something that we're going to have to figure out how to fix. But it's because of certain auto ranging that it's once you selected it, there's data from a small region of the Earth, and it tries to fit it onto the screen. We don't want that. We want it to preserve the aspect. So it's losing the aspect in a particular case. Anyway, so let's just see the area around Australia, Indonesia. And we can show that those pretty much map onto the overall distribution. But we can also select only the deep ones around Australia and see, even though it's stretched out, you should be able to see that of the ones that are around Australia, which ones are deep. It's this one, that one, that one, that one, and that one. So those 6 or so, actually I'll probably say there's 11, should be able to, if it weren't too small, you should be able to find out how many there are. But anyway, there are 3 over here. Oh, they're overlaid, that's why, a little more. Go ahead.
Just to fix the bug, maybe set frame-wise on the geoplot. Frame-wise equals true.
Geoplot. Oh, there it is.
And then one thing maybe that's not explained here, but which is worth noting, if you hold on the selection tool, just press down on the selection tool, you have various options for combining the selections in different ways. So you can, for example, apply multiple selections, intersections.
Yeah, learn about that on the large data page. You can make, so I'm just doing simple boxes. You can actually make subtraction differences. Well, you can keep adding up to make any shape you want. You can also use the lasso one. I'm not sure this works on this plot. I think it ought to, but in any case, there's lots more detail. It didn't work a few days ago. Maybe it's okay. Anyway, the point here is so we can now, now if I reset, no.
Oh,
still does.
The resetting doesn't work.
Yeah, it's the reset that causes that in general. And it resets, and so it tries to find the bounds and then stretches to fit the bounds. But we don't want that. It's being too helpful in this case. Anyway, what I want to show now, though, is that if we make a selection here, this is all happening in your browser tab. This is all dynamically updating. It goes to Python and recomputes everything and displays it. But you can now use this from within Python by calling this function here. Take your filter, your intersection, your selections object, ls2, that's what we created here. And then we linked these 2 geo and depth plots in order to create this shared linked selections. Once you do that selection, now you can get the data back. You can filter your original data by whether it's in this box and whether the depth is in this box, let's say. So now it's a subset of that data. It should just be those, and you can actually find out how many were selected exactly. In this case, it was selecting 8. So it selected 8 that were in that range and that this geographic range and this depth range. So now you can do anything you want. So you can kind of use this as a GUI already. In the next tutorial, we'll get to GUIs. But this is already kind of a GUI, which is that you can select things interactively with your mouse and figure out some set of points that you want to talk about, and you can analyze them and do exactly what you want with them. You can take this set of data, and now it's just pandas. Just do anything you want with pandas with this. So this is the way to just, if you can put any of your data, lay it out next to each other, overlay it, whatever, get it on the screen, call link selections on this whole thing, whatever you have. Here you can do it separately. You can also just do it together. Whatever this thing is that you can see, any HoloViz object, maybe not any, but in general, HoloViz object, you can do get this link selections, and then you can get it back out. Okay, that's it for plotting. The rest is about building apps, basically. Even though you saw a lot of things had some app-like features, now we're going to get on to things that become very app-like. In fact, very custom and very app-like. So I think I'll skip exercise 2 for the moment. It's worth doing at your own time. But basically, it's just take whatever you did in exercise 1 and link it up. Just see how it works. And it's not important that you, the reason I'm skipping is that it's not important that you understand that in order to run the rest of the tutorial. If you had time, you would totally be doing this. But it is the rest of the tutorial is using it, so that's why we have that exercise there. What I really want to get to is this one, because this is the fun, even more fun stuff. So now we're kind of leading, basically it's a slippery slope from the original dot plot, which was only plots, in fact, PNG images. And then we got more and more interactive. Now we're going to become custom interactive exactly in the way you want to understand exactly what you're trying to understand about your data. And the way we're going to do that is using a HoloViz library called Panel. And one thing Panel does is give you access to widgets. In this case, bokeh widgets. You can actually also use it with SciPy widgets if you're familiar with those. I'm not going to cover those here, but it can also be used that way. In this case, we're going to look at a Panel widget called a float slider. Float just means floating point, a computer approximation of a real number. So a float. And this is a slider. So this is a sliding. That's a slider. And it is a floating point value. There's also an int slider for integer and a discrete slider for categories. But this one's a float slider. And it starts from 0. It goes to 9. And it has an initial value of 6. You can always access the current value. You can even change the value. So if I did 6, 7, it updated that to 7. If I do it to, it keeps going off the screen, but it changes to 2. And you can always get the current value from there. Okay, so this is pretty straightforward, right? Panel can give you widgets. Here's a widget, and the widget has bidirectional communication between JavaScript, because this is running in your browser, and Python, which is behind the scenes. Jupyter's running Python, and whenever I change this, it will end up with a different value of the Python equivalent parameter. So far, so good. This is a slider. For it to do something useful, you have to hook it up, and this is where things normally get very complicated. We're going to show you how it can be very easy because we're doing a lot of magic. So the exercise here is to do what I just did. So you do the same on yours. Make sure you've got a widget. Make sure you move it around. You understand that there's a corresponding parameter called value. I'm actually using parameter in a technical sense. There's a library called param, and it offers parameters. Value is a parameter, and the value of that value parameter is 2.6. Okay. You could do that. You could use this to add interactivity already from the start, right? Because now you can make a selection at the top of your notebook, and then you insert a cell, and then you do 2 times mag slider value. You get some value. You can write anything you want here. You can write any expression of it. So you can have some computation that depends on the value of the slider, and you would rerun it, and you would rerun that computation. But that'd be irritating, right? Having to rerun, drag it, and then rerun. So you don't want to do that. So here, now you want to wire things up so they automatically rerun when you drag them. That's what this stuff does. hvplot.interactive. And this is going to let you build something that's on the way towards an app. Eventually you get to a dashboard. That's when you have an app that kind of fills your screen and has lots of stuff. We're starting with a plot. Eventually we get a dashboard. At the moment, it's kind of more what I would call an app once we add a widget here. So these definitions are fluid, but let's get a plot here and then turn that plot into an app. And as you can maybe guess, we're going to have an app driven by the minimum magnitude. Probably could have guessed that. So here we're just getting our usual data. We took a subset of it. This is all just pandas stuff. We did one thing, which is to limit it to what can be displayed in Web Mercator, because if an earthquake happens in Antarctica, we can't overlay it on our map because it would blow up. Literally, Antarctica takes an infinite number of pixels in this projection, so it doesn't go that far. So we're going to limit to what we can actually see in our plot. For science, that wouldn't work. We couldn't just ignore Antarctica. But for this purpose, we can, because we are just trying to show you something on the screen. So if you cared about Antarctica, you would use a different projection. You would not use Web Mercator. That's up to you. we're using it. So anyway, so let's say we've got these tiles. We only have a subset of the data, so you see it's no longer 25 columns. Philip, you're very loud typing. Maybe you mute for the second. Okay. Thank you for answering questions. But all right. Okay, so here what we did is use some pandas magic. Well, it's not even magic. We use some pandas syntax. What we did is take, we're doing a filter by minimum magnitude, and let's say we chose magnitude to be 5. This is going to filter by minimum magnitude. Look, see the only ones in this list. We showed this earlier. We showed how to filter by minimum magnitude. So we're just doing that same thing again. Now, what if we want that to be a widget? That's when it becomes an app. You make an app by taking an expression like this and turning 5 into a widget. So how would you do that? With panel, there are all sorts of ways to do that. With HVPlot.interactive, here's how you would do it. You would create this interactive version of your data frame. You've got DF2, make a new one called DFI. You don't have to name it, but we called it a name. We called it DFI, and it's the same thing as DF2, but it's wrapped up to be interactive. And now we type exactly what we typed before. Instead of DF2, DF2 mag, we have DFI, DFI mag, greater than the mag slider. And then instead of taking the head on that data frame, we take this head on this interactive data frame. Now what do we get? Now we get our slider, and we get an interactive data frame. So you may not appreciate how much magic is involved here, but try to imagine what has just happened here. We have a wrapper around a data frame. We have expressions on that data frame, such as selecting the magnitude column, comparing the magnitude column to the current value of mag slider, and subselecting by that, and then taking the head of that and displaying that. And each time I drag this widget, it replays all of that. So how the heck does it do that? How does it know to replay all of that? Well, that's the magic of .interactive. .interactive gives you an interactive version of your data frame or your data array, an X array, or other cases. It gives you an interactive version of it that wherever you put a number, with some limitations, there are some irritating limitations, and we're trying to find those and remove them. But in general, where you put a number, you can replace it with a widget. So mag slider here is a widget. You can do the same thing with just put 5. This code works just fine, but it's no longer interactive. It's interactive in some sense, but there's no widget, so you can't do anything. But if you put a widget for that, you would get an interactive app where every time you draw it, so basically what interactive is doing is keeping track of all of these operations that are being done, and it shows you the result immediately, but it also keeps track of everything you did and replays it every time you drag this widget. So this is a super helpful way to build an interactive app where the only extra work you had to do was create this widget, and creating the widget's very straightforward. You just instantiate a widget and you decide what the widget covers, and then that's what the widget does. So it's really easy to get some widgets. You can go to the panel website to find all the widgets it's got. It's got lots of widgets. This is one of them. So all you need to do is get a widget somehow. And once you do that, you just substitute your widget for whatever number or string or whatever argument to whatever method or function. This was to a pandas expression. It could have been into, let's do head int. I don't know, I've never tried this. So show different results. That one isn't going to work. Dot. Maybe I shouldn't have tried that one. So
no, you shouldn't.
Okay, I can't do int, unfortunately. And so in that case, I'd need a widget that's already an int. Let's get a widget that's an int. So where was I? Here. There are cases, like I said, that you will let's see, there's some chance that would work.
Except you missed it, the P at the beginning.
There's no in.widget. There's P in.widget. There we go. All right, so here I just added another one for something that wasn't previously a widget. In fact, this previously was the value of the head, so the head can be an integer. And that was the problem I just had there. I needed it to be an integer, and I didn't have an integer for my slider. So let's get a slider that is an integer. Pretty much, if you can get a widget whose value is exactly what you want to put in, that works well. If you have to do some transformations on it, many of them work, but not necessarily. So in this case, I just stuck the widget right in there for my value, and now I've got number 3. And now if I drag it, I get more stuff back or less stuff back. So anyway, I had never tried that before. I just tried it, and so when you tried it, you probably would have gotten stuck on the lack of int, but probably you wouldn't have even thought to try to feed mag slider in as the value of n anyway. Probably more normal people would have done this. Say, oh, I need a slider, give me an int. I need an int, give me an int slider, and that'll work. So hopefully that makes sense. This is what Interactive is doing. It gives you a replayable pipeline. That's why this is called Interactive Pipelines. This is a pipeline. First, select the magnitude from DFI. Second, create this Boolean array, essentially Boolean series, for saying whether each row is more or less than the value of this mag slider. Then subset the data to just those values. Then call .head on that subset of the data and feed in the current value of this widget. And every time you drag one of these things, it redoes all of that. So there's your interactive app. And it doesn't have to, here I'm showing a table output. Your output might be a tuple. I mean, basically it's whatever the output. If you can display it in Jupyter, it's a pretty good bet, it'll work fine. In this case is saying that as you increase the magnitude, there are fewer and fewer that reach it. And so there are, the thing that's returned is always 6 because that's the number of columns here, and you get less and less data the more you drag it. That's probably not super useful, but it's just demonstrating that the result of this, whatever it is output to your Jupyter notebook. It even works with matplotlib plot. Here, this is not hpplot. This is matplotlib, but it's fully interactive, driven by this widget, because all it's doing is every time you have a new magnitude, it calls matplotlib again and gives you the result. And of course, we would use it with hpplot. This is the HoloViz tutorial, not the matplotlib tutorial. We use matplotlib a lot in other cases. hpplot, however, doesn't support matplotlib. We would love for it to, but hpplot, it supports bokeh right now. So HoloViz supports matplotlib fully. hpplot does not. So our examples are limited to bokeh. And so you can do the same thing with your bokeh plot and drag your magnitude around and see all the distributions. When you do that, this is data science happening right here, because when I did this yesterday, I noticed something about this data. Look at this plot right here, and look at that bin. If you plot the entire data, that bin stands out. If you plot only the high value, the high magnitude events, the highest ones, that doesn't stand out. But in every other case, that one bin is much higher than all the rest. That's weird, right? So here we're able to do this is data science happening interactively right now. All I did is put a widget on a particular value for this filtering, and what it's showing as I drag that widget is something that would be very hard to spot in any one plot. A plot was just going to do a distribution. How are you to know whether the distribution is correct or not? Well, what this is showing is, regardless of how I subset the data, there's a lot of activity. There's a lot of data points right here, and they are, so there must be a lot of things. There are 80,000 events at this particular depth. Now, maybe that's the average depth of the sea or the average height of the, I don't know. Like I said, I'm not a seismologist. That demands explanation. What is going on there? And you can see it very dramatically in here in ways that don't pop out otherwise. And you can do this for anything now. Any expression you can write and visualize it in any way, just slap a widget on it. That is why we revamped the tutorial this year. Because last time we gave this 2 years ago, pre-pandemic, there was no .interactive support in hpplot. It was not this easy to build an app. Now it is super easy to build a little app. And there are going to be limits. This, like I showed before, if you try to just pass and make an int out of your widget, instead you'd have to write a little wrapper around the widget that is going to do that conversion and then return it. That can't always be done. There are, in many cases, we're going to solve that. But there are many cases that just work out of the box today, and you don't have to think about it. You just write down, you replace a float with a float slider, an int with an int slider, a string with a selector, or a discrete slider, and it just works. Or a date with a date range slider, which we will use. So I'm not going to spend any time on that. Date range sliders return a range, therefore a tuple. But we cover it just because it's going to be used later. I won't, again, I'll pretty much skip it, but it just to illustrate how it works. You can see it's nothing new compared to how you invoke it. Here you can select the date range, and that's going to subset the data based on the date, and then you can increase the magnitude, and eventually you get down to only a small number of events. Okay, exercise. That one is very silly, but there is a little bit of magic here. Whenever you patch a widget, what it does by default, if any of this code sees a widget show up, like, why are you passing a widget here? It knows when it sees a widget, find the widget's parameter named value. And that there are other things you could get out of a widget. You might find the bounds of it, you might find the name of it, but what you're asking about that widget is for its value. By default, it assumes that if you pass in a widget, you want it to be driven by the widget's value, not by its name. So, but you can specify that explicitly if you want. So what this says is that for this mag widget object, look up its current parameter value named value. All right. It's not important to change the columns here. But you can certainly work through those on your own. What is important is that we get to the end of this and you can play for yourself. So everything so far is, we just showed plots. We haven't deeply gotten into, this part's actually going to be very confusing, so I apologize in advance. If you haven't been confused enough to now, this will be confusing. Let me get to the confusing part. Okay, so first, the first thing to know is that you can, our filtered data frame here, that was there. Filtered data frame was an interactive data frame. You can't actually tell because usually it just looks like a data frame. So you actually have to keep following it back, or actually let's go ahead and see it. Filtered. What is the type of filtered? I think I covered it somewhere, but I need it now, which is the type of filtered is an interactive object. And that's all you know about it because underneath it is a data frame. We'll get back to that in a second. But anyway, here we're going to start with a filtered data frame and make one plot and another plot and combine them using our plus operator. All this does is reflect this just works like HoloViz. Effectively, it just eventually calls the HoloViz operator on the result of this thing and displays it while showing that they are both controlled by the same set of widgets here. So you can use this these widgets to control the range that's selected. So here what we're doing is it's just demonstrating that HoloViz still works. This thing would work if those were bare HoloViz objects. They are not. They are interactive objects. But it's all wrapped up and it delegates everything appropriately and it's fine. That's all we're demonstrating here is that you can take two objects that in the end when they're displayed are HoloViz objects, but before that they're these interactive objects that first have to figure out which HoloViz object you want. Oh, you want the one whose data is driven by this magnitude minimum and this date range, and does the same thing over here and then displays that. Okay, so now we can filter on things like time. You notice these are not, time doesn't come up here, but we can make this plot specific to a particular date range. Right? Maybe empty. Okay, so now we're just going to do the same thing. This also works with, let me see. sorry, this is just the same thing we saw before, just working again with, again, plotting it on a map. So we're doing the same map-based thing as we did before, but now controlled and filtered by these data points. Notice that flicker. If you drag this thing, you see it flicker? What's happening is that it's having to recreate this plot, and if recreating that plot takes some time, it can introduce a little lag and a little flicker. Somebody's wondering whether any kind of project works on Mac. I'm running on a Mac, so yes. And so you notice that flicker. So that is not a limitation of panel. Panel can have widgets that update just particular parts of the plot. That is a bit of a limitation. We have to do special work if we don't want that to happen using the simplest version .interactive. So I recommend use .interactive. If you have problems, there are ways out of them. But as long as your data is a reasonable size and you don't mind a little bit of flicker, it's way easier than having to do it by hand and tie specific bits of your plot to specific widgets. You can totally do that. You can get really responsive, highly performant, really slick looking apps, or you can slap something like this up and get your job done. So how would I start out with this?
You're also just about to show how to get rid of the flicker.
Oh, why am I? Okay. Well, this part is in a section that I'm pretty sure, maybe you should explain this one, Philip. This section, there's no reason you have to only listen to me.
Okay, you can run through it. I would have to remind myself though. Go scroll back up.
Okay.
All right, so basically what you've been seeing so far is that the interactive object, just like all the other objects that you've seen so far, kind of render themselves. If you kind of put them at the end of your notebook cell, they just display themselves, and that's usually good enough. But what it can't do is kind of figure out how to render it. And so by default, what it does is it just renders it with your widgets. It renders the output using panel, which means that it can't take advantage of some of the advanced features that, for example, HoloViz provides. And so by calling specific methods, you can kind of get just access to the widgets. You can get access to the actual underlying panel layout. So what you've done here is basically, so what you're about to do here is called the HoloViz method, which basically says return the HoloViz object, return a dynamic map which renders this content. And what the advantage of that is that HoloViz knows how to update a HoloViz plot. And so instead of kind of re-rendering the entire plot in one go, what it does is it actually updates just the data, and the plot updates without kind of re-rendering the entire contents, the entire layout of the whole thing. Which also has the benefit of that you can now use HoloViz operations on this interactive object. So you're still gaining all the features like the widget linking that you gained from using the interactive API. But you can now also apply HoloViz operations such as link selections. So if you were to kind of do mag, if you were to get the widgets off the original object, you could now basically do both. Do the interactive selection.
If we didn't do that and we didn't call HoloViz objects, what's going to happen here? You're going to be passing in
these objects that HoloViz just has no idea what the hell is this.
HoloViz doesn't know what this thing is. But if you pass in HoloViz objects, HoloViz knows what that is.
And so what we call these methods terminating methods, which basically means do not kind of continue chaining the interactive commands. Just return me the object that actually renders the underlying object. And so there's a number of terminating methods. One of them is the widgets, which just gives you a layout of all the widgets that you've accumulated through your interactive expressions. Another is just giving the panel object that renders this thing, or the HoloViz thing. So if you scroll back up, for example, we can actually go back to your to that geoplot. You could now do append HoloViz there. It's the geographic plot. Geo.HoloViz. And now maybe you want to put that into a layout with the widgets. So pn column geo.widgets.
We haven't introduced pn column yet, but okay.
Okay, yes. We're just going to create a layout. Yes. Okay, so that's a good transition. All right. It's not plus.
Sorry, comma geo.widgets.
Yeah.
So yeah, we'll get to this in a minute, which is in fact why we did not put that here yet.
Yeah.
So yes,
so
this allowed us. Go ahead.
Yeah. So the benefit here is that we're not going to get the flicker anymore. The HoloViz plot will update as we drag this. You may, however, get the aspect issues that we saw earlier, but that should be fixed by the data aspect.
Okay,
no, that seems to be working. No, there's some issues. But if you set data aspect equals 1, that should go away. So it's part of the problem here is that HoloViz just doesn't know that it should keep the aspect of the plots the same. If you were to use the GeoViz library, which has been mentioned before, it would note this is a geographic plot. Don't mess. Don't stretch things. Right?
Most data you do want to stretch to show the full avail. It's just geodata that's weird about that. And there are some other cases too. So anyway, to take a step back, well, we'd probably be confusing you, but basically what's been happening here is that if you use the default, you're going to get something that flickers a lot. And that's because it's very general and very generic. It just replays everything and updates it. And that handles just about anything you might want to do. And it's a great starting point. Like I said, there are ways around it. And if you drop back to certain levels of representation, you can do things that you couldn't do otherwise. One of them is you can make things available to a system that can do partial updates. That's a great win. Another great win is you can use link selections like we showed before. That's great. And there's some other things that don't understand interactive objects. Whenever you reach those, you're probably going to want to use one of these terminating methods here. You take your interactive object. It's still going to be just as interactive before, but then once you do this, it'll be just the HoloViz part of it. And then you display that. Or you get just the widget part of it, and then you display that. Or you get just the HoloViz part and don't display it. Get that and then do something with it, like pull out the data from it. You can do anything you want. So basically, the idea is that you've got this interactive object that mostly handles everything you want. Sometimes it's a little confusing, and we still need to work on our story for how to tell this story better. Like I said, there's a brand new story for us. But the story is that there's not a dead end. When it isn't supported by interactive, it's not a dead end. All you have to do is use one of these methods, and you'll get something that you can keep going forward and keep. Because once you have a HoloViz object, you can do anything. You can get down to the data. Once you have a panel object, you can pull things apart and put them back together in cool ways, and so on. In one way or another, you turn your interactive meta magic object that just automatically replays your whole pipeline and does everything you want. You can take that and then break it out and do work with it when you need to. And if you don't need to, ignore everything we said. Okay. So this is just to emphasize what the point of this notebook was. It was actually quite early, right at the beginning. This first one here, although I added another slider. But this is the point of this notebook. You can take something that works, that is a pipeline that you can play something on, and you can replace any bit of it with a widget, and you'll get widget plus whatever the output of this thing already was, controlled by sliders. That is the point of this notebook, and that's what I want you to take away from this. This stuff about how terminating methods is important when you reach the limits of it, but you don't have to reach the limits very often. It's only when you get ambitious. And so we really want you to focus on this aspect here, which is that you can have something controlled by widgets, and it's going to replay it, and you get the output. That's what matters. And then that brings you to exercise 3. So now you should be starting on that, and we have I think it mentioned 15 minutes. We'll see how people are feeling after 10, but so it'll certainly take at least 10 minutes. So exercise 3. All these exercises start out the same way, and just load some data, and then you'll do exactly what I just did. You've already seen a minimum mag slider. The first thing you do is make a minimum depth slider. This should be very straightforward, the first one. So this is just our data. And now you're going to do the same thing for depth that we did for mag. So I'll wait a bit so that I don't jump the gun, but anybody else, hopefully you're working through this. You try it yourself. You go back to that tutorial we just did and steal anything you want. And then come back to the building pipelines tutorial exercise 3. All right, don't mind me if you're happily working, but if you're running into trouble, you can watch me run into trouble while I try to do it.
Hey, Jim.
Yeah.
So someone had a good suggestion, which is to remove your toolbar. If you click on View and then just to give you a bit more vertical space. Toggle toolbar, and maybe even the header.
Yeah, I don't think I'm going to use that or anything. Yeah, and I can also go in full screen, but I find it irritating. I like to know where I am.
Yeah.
All right, sure. Okay. Oh, whoops. Okay. Oops. Philip, any idea why this is only taking half the screen when I told you? It works. Yep. Okay, the alarm told me that screen share was off, so it seems like rather than alarming, it could just re-enable screen share, but whatever. Philip, are you muted? Can you tell me why this happens? In case someone else is getting... Anyway, I won't bother. I won't go through the data array myself, but similar. You can just demonstrate to yourself that the .interactive works fine with X-array. In fact, it was first implemented for X-array as part of our work with the PenGeo project. We're not geoscientists ourselves. We're a lot, but we play one on PyData. But we do a lot of work with geoscientists, and so that we first developed that for X-array, but then extended it to include pandas as well. All right, I think 5:15 is a good time to call that one, and then we have one more section. If you look at how these things added up, this is the end of the tutorial, the part that's marked optional. I should have alerted you to that at the beginning. We were now planning to get to this part. So if you total all those, that covers the tutorial up to the end of this exercise 4. So what we're going to do now is go on to dashboards and then exercise 4. So that's what's remaining in the tutorial. And so these other, and the reason for that is that we've tried to give you enough time to try things out and get used to them up to this point. Beyond this point, you're going to cover topics that don't use .interactive. They use panels native API, and they aren't limited only to HVplot. They use the HoloViz native API. So for beyond here, you have to learn to be able to do this stuff. And we don't want to just promise. So basically, our claim to you is that going through this tutorial and learning a little bit on your own should be enough to cover the whole content up to here. Beyond that, you'll have to do additional work that we do not cover in the tutorial. We demonstrate in the tutorial, and you can see how it works, but we don't cover it in detail. And that work is to learn more about panel, learn more about HoloViz. You get all sorts of power to dynamically update little bits of everything exactly the way you want it, lay things out exactly how you like it, plot exactly how you like it. That's all great if you want to spend that much time on it. But up to this point, we feel is the point where this is valuable to just about anybody. Pretty much anybody ought to be able to create a plot using your Python data. You ought to be able to get the types of interactivity that we're showing here. You ought to be able to do this last section that we're about to do here of putting together the dashboard. We would like to have that be the minimum that you would expect people, Python data scientists, to be able to do. And this extra stuff is advanced. This is for people who are going to put a lot of effort in. And you get more out of it, is true, but it takes a lot more work. Up to this point, we would like to defend the idea that most people should be able to get up to here, spend the time of this tutorial, literally today, the 4 hours of this tutorial, and then some more work on your own for maybe another 4 hours. Then go off and do it, and it should just work. And when it doesn't work, it's an error in our tools or a limitation. When it's a limitation, you will have to learn more here, and that's fine, or you just decide not to do it. We are firmly committed to the idea that that is okay. You do not have to learn our internal APIs. They're not internal, but from the point of view of HVplot, it being built on HoloViz, that's a detail. And if you don't want to learn about that, fine. You just don't control that aspect of the plot. You accept the default. You don't fiddle with it and change it to make that one little thing be exactly the color of your company's logo. If you want to do that, you're going to have to learn more, but we would argue that up to this point is going to be valuable to just about everybody. So that's explicitly how we designed this entire tutorial, to cover what just about everybody needs when you're working with data. And maybe you didn't know you needed it. But this is stuff that's actually not hard to use. It's pretty straightforward, doesn't fill up your notebooks, and gives you stuff that is valuable. That's what we believe. So now we're going to launch into this last section here, how to put those things together. You have to learn a little bit more, but when you do, you can make a whole dashboard of the type that we're showing. Okay, so let's just dive in so you can quickly get to the exercise where you're trying all this stuff out yourself. So what we're starting with is panel now. Panel is, you've already seen panel widgets, and then Philip snuck in a little reference to panel column. That's a panel object called a layout or a panel. That is that's a collection of objects that you display together. And so, but panel has lots of stuff in it. And first off, we're just going to talk about a little bit, some features of panel that are useful, when you're building a dashboard, you often need things that are not plots. And those are also things you can get from panel. Panel can display lots of things. For instance, here we just loaded some libraries. We ran this. This will become apparent later. You didn't have to. You do have to run the panel extension if you're not using HPplot. HPplot is called automatically. Note what we did here. If you want to do some special things with panel extension that we'll get to later, like use a special template, then you need to make sure you do that before you call HPplot. This is kind of important. It won't be important for the first part, but for later on in this, it will be important that you did this in this order. Otherwise, you get an error if you've called HPplot before you call this thing and set these settings on it. So basically, this is configuring panel to work a certain way. And having configured it, then you just use panel. For instance, you can use a concept of, it's called a pane. It just happens to sound like panel, but it's nothing to do with it. A pane is like a window pane. If you have a panel that's a large set of things, one of the things in it is called a pane. Like it's a little chunk of things that you lay out next to each other. And there are lots of pane types. This one's Markdown. Markdown can include, it includes HTML, so you don't really ever need to use HTML. Just use Markdown. So you can put HTML in here. So any sort of string that you want to format, this is just the Markdown for making a big header, and this is HTML for making italics. Just make a string and it'll display it. So this is HTML. As you might expect, there's a PNG pane for PNG, a JPEG pane for a JPEG, and so on. The data set we used in this tutorial is from USGS. So this is the logo of the data set, the creator of that data set. Instead of this string here, which refers to a local file on this server, this is my laptop, so it's referring to local file on my laptop. But if I had it on a faraway server, it'd be referring to a local file on that server. Or we could put a URL here, and that would be dynamically fetched from somewhere on the internet. So this is a PNG pane. Everything in panel every pane has its own type, but mostly just don't even worry about it. It's called pn.panel on something, and it'll generally figure it out. It'll figure out whether it's a PNG and get a PNG pane, whether it's text by default, it assumes it's Markdown, because Markdown subsumes HTML. So it'll work whether it's just text. Markdown for just text is text. So just the so by default it assumes if it finds a text, the highest it actually scans all the available pane types and finds the one with the closest match. And for a text, the closest match is if it ends in one of the known types like PNG, even if it's URL, that knows, oh, that's going to be PNG. If it doesn't, it assumes it's Markdown. So you can force it if you want to, but typically just don't bother thinking about it. Call pn.panel, and if it's great, never look back. If you want to change it, then you're going to have to do some work. So time for an exercise, which we should have left you a little cell for. So use the type to figure out the type. There's a type pn.pane markdown, and it happens to be in the markup module. You can also import it directly from panel.pane, which is, I believe, yeah, we're just using it in pane. So the actual source for it is in a subfile. Don't just ignore that. Okay, so now it says to explore. So etc. Okay. Philip already sort of jumped the gun on this, but he showed you a pn.column. There's also pn.row, and this is a row of the title and the PNG we defined earlier. And we defined this thing total to have a height of 40. If you did a height of 10, it would make the image very small. Basically, it's a row of two things. And so you can do a column of a row of a column of things and come up with any hierarchical thing. Now let's again open our same data set, same thing we've been doing. So I'm ignoring all this code. We've already seen all of it. I think, yeah, this was detailed, but the data didn't have nans in it. I don't think we mentioned that, but this is just make your data set behave nicely. Always your job. Okay, and now let's make a mini dashboard with a plot, with an overlay and a title and a logo. This is when this becomes dashboards, because it's a slippery slope between plot and dashboard with any of these tools, because they're often highly interactive. This one, at this point, we'd call it a dashboard. It's like the simplest dashboard ever, but it's a dashboard with some text on it, an image, and a plot. No current widgets at the moment, but we'll add some in a minute. And now this is what it takes to make it be. If it's a dashboard, you should be able to visit it as a standalone app. And what we just did there is we took this thing that was already displaying in our notebook. I probably messed with this, or this would be better organized here, better formatted. But I just called .show on this thing that was this panel object that was displaying in the browser. I called .show on it. What .show does is launch an entirely separate view of this data. Notice we're no longer in Jupyter. We just escaped Jupyter, open a new browser tab, and we're looking at something that's listening to this particular port on my machine. And now this is the sort of thing you could share. Now, you probably wouldn't share it this way, where you launch it from Jupyter, and I'll explain more how you'd launch it really. But this is what you would share.
So quick note here, if you're running in Binder, this isn't going to work because it's basically launching in a different port, which your local system doesn't have access to.
Right, it'll be firewalled away usually. So depending on your circumstance, a lot of the time, if you're opening and listening to a different port, you just can't do it. If you're behind a corporate firewall, if you're being blocked and various things. So this works in this case in Jupyter. You might have a Jupyter notebook on some other server like Colab. Probably won't work there. .show. So, but it does. If it does work, then it'll give you an idea what your final app would be. But really, you wouldn't do this. This is mainly for debugging. If you have access to such a debugging environment, then definitely use it. But otherwise. Okay, so we'll close that one and then go back to where we were, which was here. Okay, so we did .show, and you'll see that it launched a separate server, and it had a host you could look at. You don't really want to do that. What you would use, though, is you would this. You would do panel serve, actually up here. If I had written, wait a minute, now instead of .show, if I'd written this, if I'd written that and then saved this, and I typed this command to the command line. I won't do it right now because we're actually going to do it with a different notebook in a minute. So I'm not sure why I mentioned it here. But anyway, this is a tiny little dashboard, and we take this dashboard, we mark it servable, save it to disk, and then panel serve in the name of this notebook. What it's going to do is ignore the fact that it's a notebook. Just take it as a set of code cells, run those code cells, and if there's ever anything marked servable, that'll be an object that it's going to put into the final app. And if it's not marked servable, it just runs it and moves on. Nothing, very straightforward. In fact, it worked exactly the same. You took all the code in the file and put it in .py file. It ignores entirely the fact that it's in a notebook, .servable. But if you do it in the notebook, what it does do is just show you your thing. So here it's going to show me another copy of my app. So servable is it's always safe to add that servable on it. The notebook doesn't care. It just ignores the fact that it's servable, and it just marks it as something you would serve later when you run this command line function thing here. Oops. Oh, I meant to do this. Turn it off. Okay. Hopefully that makes sense. If you really want to take the bigger picture, you have to think about, where am I going to run this thing? How am I going to share it to people? How will I deploy it? How will I set up a Python environment in which to share all this? I'm not going to answer any of those questions for you. That totally depends. You could certainly go to Amazon and rent a server on it and run it there and basically it's like running a web server. You can totally do that. You look at the panel website, there are all sorts of options for deployment. You can use Heroku, you can use lots of things. Though that's your job. We're going to get you something that is servable, and it is your job to serve it. And serving it just means launching a process on typically on some Unix server of some sort, some Linux server somewhere in some data center. If you can launch a process on there and you can have it listening to a port that is not blocked, voila, you have a server version of it. That's deploying. Deploying is different in every different organization. Our company sells you products you can buy that make deployment be one click. That's great. Most people don't have those, so most people have to think about this and get permission from IT or just do it on your local laptop. Anyway, to move on so you can leave some time for trying things out. Let's just do, all we're doing is same thing we were showing before, is just making some interactive widget-driven plots. All we're doing, so you've already seen all this, and then we just take what Philip showed you, which is to put a column with the header, which now includes these widgets. I actually don't know where that happened. Happened in there somewhere. Where's the header? Yeah, somewhere up there. Anyway, and then puts it in a panel column, and now you have title, logo, widgets. The widgets are wired up, and you can take this thing, whatever it is, and then do .show, and it'll launch it as an app. There's your app. Now it's got widgets. And as shown, see it flickered like before, but we already showed you techniques for avoiding that, or just decide not to care. We're not, I don't know why I'm on binder, but okay. So then this is all we're leading up to, and this is everything in this final app here is stuff that we have covered in this tutorial, but maybe not with enough, maybe we breezed through it and you didn't quite get it. So our claim is that somehow in the preceding 4 hours and in this material, the preceding 3.5 hours, we covered everything necessary to make this final app. And the final app includes a geoplot, overlaid data points, hovering, a table that's, I'll get to the table in a second, histograms, selections linked between these guys. So link selections, those covered earlier, and laid out, and having widgets and a title. So that's what we led up to, and our claim is that we covered enough for you to follow all of this. Now, I'm not going to go through it in a whole lot of detail here. I'm just going to point out the new stuff here. Number one, so starting from here, new stuff is we're going to use something called a template. And this is, you can have all sorts of kinds of templates, whatever. There's a default template that we defined earlier. So I mentioned before, we're doing something special. Right here, we said our default template is going to be material. So material is a JavaScript library. It makes pretty web pages. And we also added support for this table, which is otherwise an optional extension. So we did that earlier, and now we're going to make use of it. So now here we're going to say that we're going to have the template. Template has various parts. Typically, a template has a sidebar. In fact, let me go ahead and launch it so you can just see it, and we'll go back and forth between the actual app and the code, so you can see where it came from. So let me launch it. I am off screen right now, but all I am typing is panel serve 06 dashboards, but I have to find what directory I'm in. And I probably ought to remove all the junk that I've been typing here. I hope I didn't break anything, because basically if I did something interactively that is incorrect, this panel serve is going to try to run this entire notebook here, and it's not going to work. So let's see. Maybe I didn't mess anything up. If I put a syntax error anywhere earlier, it would have messed it up. So let's see. Fingers crossed. I was only editing valid things. Philip says, tabulator extension not recognized and will be skipped. I assume that only matters in the notebook. That's my assumption anyway. Okay, and it shows that I am not running the right version of the software. So, in fact, why don't I just type it in the notebook? I'll type it in some other notebook just so I don't have to do any work here. So. Okay, so. This is not good practice. But it lets you see what I'm doing because I have my other window you can't see. So let's see. Okay, so I'm just running this command here, and I had to use a different. I had to specify a certain port because I've got a billion things running because of this tutorial, and I've already used up all the earlier numbers of ports. So the default number is I forget what it is, but it's not 5099, so that works. So I've launched on this. Launch that, and I'm clicking here, and there are things you can do to make it run very quickly. Pop up an initial page and put a spinner and make it be highly responsive and make there's experience for the second visitor very much faster than the first because everything is cached and you can handle lots of users and all of these things. I'm going to cover none of that. We just did it the pretty straightforward and simple way. And so here we just launched an app, and here's what happened before is that I said I might have screwed it up, and I did screw it up because I marked something else servable that is not this final app. So let's go back to it, and I'll go back and show the command again, but I marked something servable that was not meant to be servable. Let's see. Yeah, I'm just going to actually revert this entire notebook to how it was when we started, just because I don't want to figure out what all I might have changed while I was trying to explain things to people. So I'm going to clear it and then reset it to the original. Okay, and then here's the command I typed. I happened to be in the exercises directory when I typed it. That's why I had to do this stupid thing. And then I chose that. So all I did was, this is my app as it's being put together. So somebody had asked, this is the command that I typed. And what it's doing right now is that because I just launched this, it is loading the data file from the disk. It's doing the various initial data processing steps and whatever. And with an app like this, if you write it by default, each new visitor, that happens roughly for each new visitor. So if you think about scaling and you think about responsiveness, you probably want to try to cache things and not have every new visitor have his own copy of the data set. And in most apps, there'll be one data set and lots of visitors. And so there's various state caching and so on that you can do to make sure that works well. We're not going to cover any of that. Those are for, our goal is to get you an app as quickly as possible. And then after that, it's up to you. If you want to optimize it, it's completely possible to optimize. but you shouldn't have to optimize it, is the thing. Okay, so let's just, okay, so I just launched that again. I don't know what that other one was doing, but I don't care to debug it because I did it in some random exercise notebook. So now it's the actual one. All right, and so somebody asked, I think, a good question. Tell me again about .servable versus .show. .servable in the notebook does nothing. Nothing. It's not nothing, but it does. It's not necessary for the notebook. Typically, there's no reason to do that if you're just using the notebook. What it does is mark something that if you ever ran panel serve in the name of the notebook, it would find that object in the notebook and display it. If you do .show, that does something immediately. It launches this whole separate server. Now, this server that I launched was with panel serve from the command line, although I cheated. I did it in a notebook, but essentially this is the command line. All it is doing is running to a terminal prompt in my environment and running this command. And so what that command did is launch this app. It would look
a bit better if you zoomed out.
If I zoomed out of here.
I think no, your browser zoomed in still.
Oh, your browser zooming. Yeah, I have it up way high, and it's making the text really big. Yeah, and that's another thing you can spend tons of time working on, is making really responsive apps that look good on a mobile, that look good on your phone, that automatically resize in various ways. There's lots. You have lots of infinite sinkhole of making it beautiful and responsive and performant. You can totally do anything. And our job in today's tutorial, for which you have 20 more minutes, is to get something working basically. So this should be working basically. You should have your usual selections. You should be able to select on here. The selection should be reflected in the table. But I want you to have some time, so I'm to get some feedback. So hopefully you probably already started yourself because I got to the end of it. But you should, if not, please start on exercise 4. And exercise 4 is just giving you, the first parts are pretty trivial. The second part is that you can also use equations. And then gives you things to try. You don't have to try this though. Just try whatever you want. This is the part. In 20 minutes we're going to be gone, so try whatever you want to get feedback on. And the panel serve line can be done in less than a second. Somebody asking a question, how long does that take? It could be less than a second for a quick app, and it could take 5 minutes if the startup of the app requires contact some remote server and download 2 gigabytes of data and then start. It's Python. So basically it takes as long as Python takes is the answer to that. And like I said, there are ways to make it start up much more quickly and to give responsive spinners that reassure your users that it's working. Those are, like I said, spend as much time on that as you want, put as much hand-holding and reassurance to our users, but you don't have to. You should be able to get something that comes up without much work. Yeah, and if you want to stay in your notebook to run this thing, just put a little exclamation point. That's how you do it in the notebook. And the good thing about using Notebook is you know you're in the right environment, whereas if you open a command prompt somewhere on your machine, like I just did, it happened to be in the wrong environment. So. And at this point, we're just answering questions, so please ask questions.
Now might also be a good time to mention the discourse, where you can, once we are no longer here to ask questions, you can go to the discourse to ask your questions there. So it has individual sections for all the different libraries. And we'll try to get those, get to your question, or the community is pretty good about trying to answer things as well.
That's right. Discourse we have no more rights. We have sort of moderator rights on the discourse. We expect people to jump in and answer each other's questions on the discourse. On GitHub, sometimes people do answer each other's questions, but on GitHub, it's for reporting specific problems that we need to do something about as maintainers. GitHub, you're talking to us, the maintainers, and you're recording things so that other people might see it, but it's not meant for people to chat with each other. Discourse, from the name, hopefully, is for you to have chats. And so you can say, hey, how would you do this? Or look at this cool thing I did. And somebody says, oh, how did you do that? And so on. That sort of stuff that goes on discourse. Oh, and this is a good reminder. I wanted to actually mention, for anyone who's paying attention, there's another project that I'm not going to mention today and is not mentioned on holoviz.org called Lumen. This is new. We don't have a logo for it yet, but this is something to look at if you want to not write Python and make similar dashboards. It's the same sort of dashboards we're covering today almost entirely, but driven by a YAML specification for what you want each plot to be and how you want them linked up. So check that out if you want. And there's even a brand new GUI version of it so that you can work on a team. You do this cool stuff we did today. Your buddy goes way deeper into low-level stuff. Your other buddy writes a YAML text file, and your other buddy just uses the GUI builder and makes all this. And all of you can exchange apps. All of them, you can deploy them the same way. You can use components from them and each other. And so you can have this whole interactive capability of your organization, regardless of whether you know Python or not, whether you're comfortable editing text, and whether you're comfortable editing, how deep do you want to go? Depends, like how much do you want to mess with it? So anyway, it's new, still rough edges, but should get you there. It is by Philip, who's on here, who's also the original author of Panel, and then and HVPlot, in fact. Jean-Luc is the very most original author of HoloViz and contributed to all of these things. And I am the original author of Param, probably. Designer of Param originally, but everything's based on. The author is actually Jeff Prevost, who's not here today, followed by Chris Ball. Anyway, these are all projects that have been around a while and had a lot of contributors and a lot of community involvement across there. So I can't thank everybody. That you have to go to the websites and get to find everybody involved. People are wondering how many people use HoloViz, and we have no idea. We can see that, actually, that's another thing I didn't cover. PyViz.org. This is we run this site too, but it is not about HoloViz. It's about every possible thing. If you look at every possible thing, you can see which things are popular compared to each other. Just compare their downloads, but those are very confusing numbers. They might, if it's used 1,000 times a day in some continuous integration job, that number will go up by 1,000. So it's hard to tell, but what you can tell is that 20 million people use matplotlib per month. 2 million people use Bokeh. So matplotlib is more popular than Bokeh. It's very widely used. And so if you scroll down and find HVPlot, where that's over here, that's 50,000 people per month. That's a lot less than Bokeh. On the other hand, Bokeh is a much older library, and Bokeh has lots of things built on it. Like HVPlot is built on Bokeh, so is HoloViz, so is Pandas Bokeh. Lots of things are built on Bokeh, and whenever anyone downloads those things, Bokeh's numbers go up. So if you compare two things that are comparable, HVPlot and Pandas Bokeh, a lot more people use HVPlot built on Bokeh than Pandas Bokeh built on Pandas Bokeh. That's a data point. You can compare stars. You can see how many contributors. We can't really answer that. You can also compare Conda versus SciPy. Like Bokeh is much more popular on Conda than Plotly is. A lot more people use Bokeh on Conda than use Plotly on Conda. And so this will tell you a little bit about who's doing it, because Conda tends to be used by data scientists rather than systems integrators. So anyway, we can't answer that. We're interested. We spend a lot of time talking to the people who do use it, though. So that's what we know. And I do think that it's underused. I think it's useful to very, very many more people than who currently use it because they've never heard of it. They don't realize that it's as easy as this. And hopefully you guys can go evangelize for us and tell all your friends about it. It's all free stuff. We don't earn any money when you do, but we sure would like people to get stuff done better than they're able to do now. We don't have a marketing department. Anaconda does. This is all open source tools. We don't have an open source marketing department focused. Let's try to get more people to use HPplot. Anaconda has one, and we work for Anaconda. Anaconda will try to show off the amazing things you can do with Python so that you'll pay Anaconda money. That is great, but it doesn't directly, it's not directly about trying to get people to use these tools. We just produce these tools. We work with customers. If you want to use these tools in your own work and you have a budget and you want help with it, we will help you with that. But mostly these are just open source tools that we use in our work, and we maintain them as part of our work. And if other people use them, we're super happy, but we earn no money. People are asking whether it is actively maintained, developed, and supported. Supported is a big word. We do not promise to fix a problem that you raise. Neither does any open source library in the world if it becomes popular, because there could be an infinite number of problems in different circumstances. It is actively supported and maintained in some sense. Well, I really wouldn't use the word support. Open source libraries are not supported. There is no support desk. There's no one you could call who's paid to staff it and respond to your problems. Instead, we have things like Discourse. You can go there and discuss with other users. And if you find something interesting, we'll jump in. The maintainers, we will say, hey, that looks like a bug. Will you report it? Or I don't know either, or whatever. But it is not supported. It is maintained, and it's something we've built. My entire group runs on this software, and all the money we ever get and all of our salaries all depend on this software working. So we are very much committed to keeping this software working. We have all this continuous integration set up with constant releases. We do a whole lot of work maintaining this, and we are paid to do that. That's part of our jobs. We're paid by companies basically who need features out of all of these tools. So there's plenty of, there is support, and these are highly maintained. But you can't use that word. It is not supported. It is maintained. It is 100% maintained. It is developed. It is very actively developed. You look at our GitHubs, you'll see that there's a lot going on. We do a lot of work on this.
And that's probably a good time to chime in. Some of the stuff you've seen depended on packages that are not entirely released yet, or the latest versions that you were using weren't entirely released yet. We will be pushing out new releases of pretty much every library used here in the next couple days.
That is a very good point. Let's actually reveal a little bit about how that works here. We're using Anaconda Project. If you're familiar with Conda environments, it's basically a slight generalization of Conda. And in fact, we're trying to get it incorporated into Conda itself. There's no reason, it should be Conda Project. Just for historical reasons, it was called a separate name and it came about slightly different. But basically, it's like Conda, except for a couple of super important things. So like Conda, it lets you specify the packages you want to use in your environment. Unlike Conda, it pairs those with a command that this command is meant to run in that environment. And so what it says is this combination of packages plus command will work. This is a capturing of a reproducible environment plus a command that is, if you run this command in this environment, it'll work. And Anaconda Project takes care of instantiating this environment, running this command. So if you do Anaconda Project run dashboard, it'll run that command in that environment. And so basically it's like Conda, and then this is why I brought this up. You'll see here all of the libraries we're using today, all the libraries we're using directly. And there's another file that'll show all the libraries we're using. That one you don't want to read. That environment has all of these libraries in it. And really it shouldn't be putting them there unless they're used. And so apparently we're using that many libraries. So this is what we're definitely using. And mostly we're not using any special features. We just want the latest versions of whatever. Like matplotlib, pretty much any matplotlib library will work. SciPy NPL, that's what makes matplotlib widget work. Bokeh, we want the latest bokeh. This was released last week. Datashader, we're not too picky about Datashader, but we're very picky about these last ones here. Look at those version numbers. This was released last night. This morning, I think. This morning. These were all, there's about to be a panel release, 0.12.0. This is release minute at number 10. It should be.
Look forward to a blog post announcing the release. There's some cool features in that release.
Yeah, so you're getting bleeding edge here. If these things do work in this environment, as you've seen, but they require these specific, very latest versions. And so you wait a week or 2 weeks, you won't have to say this. It won't be that anymore. It'll be 0.8.0 and so on. Hopefully that makes sense. We're showing you things that we developed specifically to make your lives better, to make things easier for you, to try to make things work more straightforwardly, to be easier to approach and easier to learn using the APIs you already know. We've spent a lot of work on that, and that work is in these dev releases. We're trying to make your life easier. We're doing the work, but it's so that people can more easily pick up these tools, quickly get to a solution, and move on with their lives. We want that for our clients, our commercial customers. We want that for the whole world. The whole world isn't paying us. Our commercial customers are. The latest work that we did here was not for any commercial customers, just for SciPy, just to have it ready for this tutorial. And then gradually it'll get better and better with commercial or research or government support. Hopefully that makes sense. And the other thing that this file has in it, apart from the commands, is the data. And you'll see that if you want to figure out where to get any of the data, you can do it all by hand. You just grab this file yourself and pull this out and put it in that, put it in this file and so on. This is all explained. This is the right point. We've got 5 minutes left. Where do you go from here? It says it in the at the end of our last dashboard notebook, which is here. No, that was the exercise. This one. If you go to the very end of it, it says, where do you go on from here? Because this is a sort of stopping point. There are 3 more tutorials. We're not going to cover them today. They're on the website. You can cover them yourself. But where do you go from here? First, you go to hvplot.holoviz.org, and you'll see all about hvplot. That has all the documentation. You can read all about interactive at hvplot. And then the second thing is to go to examples.pyviz.org. And if you go there, you'll see lots of examples of things. You'll see they're tagged by which tool was used. Not all of these use, I think they currently all actually use the HoloViz tools one way or another. Some of them are things like Voila, but that's actually deployed using HoloViz. Anyway, this doesn't have to be HoloViz, but it is a lot of examples of HoloViz tools that we had a hand in. And they're just captured here. Each one of those has an associated Anaconda project. So each one of them is a reproducible example and a command to run in that, which is generally a notebook, and then something you can explore. What we have not done is put a date on each of these. We've been doing this for years. We've been at Anaconda for 6 years now, and we've developed a lot of these. And each year we make a better example. It's more amazing, and we put it up, and then we move on. And so these come from all different eras. In fact, all of them predate .interactive, every one of them. So each one of these, you'll see things that are the sort of thing that you can do with .interactive. You'll see the other way to do it, the original way to do it, the harder way that gives you more control but more power. It gives you more power and more control. It's harder. Actually, I don't know where all the white, somehow the white space is gone. I mean, labeling. Anyway, so this is a great way to see what's possible in HoloViz ecosystem. And you can totally do what it says there and use that interface, but we haven't told you how to do it. So that's where our next job is to take all the tools that we listed today, scan through this list and see what could we re-implement better nowadays, easier with .interactive now that we have it. And I bet we can do that one real easily. We can probably make a good version of that. Probably that one. And then there's some others that will require advanced techniques. So we'll scan through that. This is volunteer effort here. This is just about making good examples for the public. But we do want to update these things to say, hey, there's actually this really easy way to do this. It's pretty straightforward. We recommend it in most cases if you don't have deep needs. So that's just a warning. You can see all these examples, but you're not going to be able to understand the code as well. But hopefully the code is already straightforward enough that you can dive in and at least run into your first problems with what you've seen today. All right, any final answers, final statements from Philip or Jean-Luc before we adjourn?
I'll just say thanks for joining us, everyone. It's been great having you guys here. Do join us on the discourse, even if it's just to introduce yourself. I'm going to make an introduction category there, and post any questions you have for us.
Thanks, Philip. I don't know if Jean-Luc, you're looking around back there.
Yeah. Again, thank you all for joining us, and don't be afraid to file issues. If you find problems, just go to any of our repos and file a GitHub issue if you have something to report.
And thank you to Kristen for setting this up, and to Jean-Luc and Philip for answering all those questions. I can't keep track of all of them. It'd be interesting to see the transcript later. But thanks everyone for participating, and we are excited to have you at least potentially using these tools and showing off. That's the last request for you. When you get something cool, tweet about it or publicize it in some way and tag us so that we know it's happened. So on Twitter, each of our websites, if you go to it, there's usually a little Twitter logo, and you can see our Twitter feed for that project. So just tweet about whatever project is in there, and we'll see it. We'll see your cool new plots and your cool new apps. Thank you, and good luck, everyone.